All right, so let's go ahead and get started. So my name's Justin Searle. I'm a managing partner with Utilisec, and have been here in the security profession for the last 12, 13 years. For the last half of that, been pure penetration testing. Before that time, I was doing much more of the defensive side. Specifically, over the last 2 to 3 years, my area of expertise in all my research has usually been in the energy sector around smart grids, smart meters, SCADA systems. But I still do a lot with web applications and penetration testing of web applications. In fact, this is my project, the SamuraiWTF. Myself and Kevin Johnson run this project, and I've been running it for about 3.5 years now, with about 12, 13 different releases of it. So I still do quite a bit with web applications. In fact, for those that aren't aware, when we are dealing with critical infrastructure and SCADA systems and smart grid systems, many of the user interfaces, as well as the machine-to-machine services between the critical infrastructure systems and the rest of the IT systems, are using web applications and web services. So once again, you can take this knowledge anywhere you possibly can, and you find it applicable wherever we possibly are. So now, quick raise of hands. How many people in here have performed penetration tests on web applications before? Okay, so we have many of you that's in here. What we're going to do during this workshop, as I mentioned, this is taking different excerpts from the training course that we do here at Black Hat. The training course is really targeted at beginning to intermediate levels. If you have a lot of experience, you may or may not find value in this workshop, just to be very, very upfront with you. We're going to be working through 3 different sessions today. We're going to be going from now all the way until lunch. The first session, I'm going to be going through and describing SamuraiWTF, doing an introduction to it, talking about the project, giving a walkthrough of the different tools that we have available on it, as well as starting to do a basic penetration test of a very, very simple application. The second session, we're going to continue that trend and doing a penetration test. We're going to be first starting out doing a penetration test of one application using some very, very simple tools inside of Firefox, really focusing more on manual techniques, talking about how we go through and manually map the application, just little teeny tricks that really kind of mess up a lot of basic and beginners to penetration testing. So towards the end, we start doing more with, more towards the intermediate techniques. So if you do have some experience, you may be more interested in the latter sessions rather than the beginning sessions. So that's what we're going to be working on. So our goal over these next 4 hours until lunchtime is to try to go through and perform penetration tests of 2 different web applications using a whole handful of tools, and talking about not just how to use these tools, but how we can integrate these automated tools and semi-automated tools with our manual testing techniques. Because one thing that makes a difference between a good penetration tester and a great penetration tester is being able to not just use the tools that are out there and be able to read and interpret these results, but figure out how to integrate their work process with their manual techniques as well as these automated tools and try to make them work together seamlessly. So that's really what we're going to be trying to focus on inside of this course. This course, if you have a copy of that USB or you see it floating around, the slide decks for the whole 2-day course are available on this USB. Every single time I teach the course, I do major updates to the course. So this course, I do release under Creative Commons license. So if anybody wants to use this material, please feel free to use this material. Just please, honor the license is all I ask. So use it inside of your organizations. If you start watching on the SamuraiWTF website, I have been updating every single time I put out a new course. I have been updating and posting that to the Samurai website. So if you watch that, you'll be able to get the new updated versions of the course as we do new versions of it. Just a quick props to some of my other partners with the SamuraiWTF project as well that have contributed to this course and given some feedback. So I'm the primary author of the course. We do have Kevin Johnson, who runs the SamuraiWTF project with me, as well as Raul Siles, who also helps run the project. Both of them have contributed to this course, so I want to give them some props as well as the companies that sponsor each one of us. This is the course outline for the 2-day course. Once again, we're going to be jumping around. We're going to go through and do an introduction to Samurai and very briefly hit just the first couple slides on the methodology. So we have a methodology to discuss, a framework to be able to proceed with the rest of the workshop. And then we'll jump right into doing the testing Matilde, our very first application to test. We'll run through that one rather quickly, and then we'll jump down to DVWA and be able to work on DVWA. So that's what we're going to try to get through as much material as we possibly can in the time that we have allotted to us. So, SamuraiWTF, Samurai Web Testing Framework. For some reason, everybody always messes up that acronym. It stands for Web Testing Framework. It was very strategically chosen, but we have enjoyed having the project over the last few years. Right now, we do have the distribution as only a live DVD. At one point, we're releasing virtual machines. However, we all know that each one of us have our own preferences for virtual machine software. So we've actually stopped releasing the virtual machine version, the VMware version, and only release the ISO anymore. This allows us to use that ISO to boot up inside of any virtual machine that we have. It is based on Ubuntu Linux. The version that we are running right now is actually running on the previous LTS release. We are right in the middle of releasing Samurai 1.0 that will be released here probably in the next 3 to 4 weeks. That has been fixed and is running on the current LTS release of Ubuntu. Not the one that's going to be released next month, but it'll be up to the previous LTS release. I am currently working on doing a 2.0 branch of SamuraiWTF that will be tied to the release that's coming out next month from Ubuntu. So trying to keep it in line back with Ubuntu. We had a lot of issues with library compatibilities and dependencies, and that's what kind of forced us to fall out of line with Ubuntu. We've now been able to address those and fix those. We'll be releasing that, as I mentioned, just here in a few weeks. With this distribution, we have over 100 different tools, extensions, and scripts to help us perform web application penetration testing. You can see some of the major tools that are up there, but these same major tools are on almost all the different pen testing distributions, like with Backtrack and many of the other ones that are out there. So one of the questions we often have is, well, what's the difference between SamuraiWTF and Backtrack, as well as some of the other distributions out there? Really, when we look at Backtrack and Node Zero, a lot of these other live pen testing distributions are geared towards network penetration testing. So they can do web application, but they can also do many other types of penetration testing as well. SamuraiWTF focuses purely on web application penetration testing. If you go through and compare just the tools that have been installed, SamuraiWTF usually has many more tools than what Backtrack would have for web app pen testing. So when I perform penetration testing of web applications, I will use SamuraiWTF. If I'm doing network-based penetration testing, then I personally will always use Backtrack to perform that type of work. So I generally choose the tool that works best. Other differences, SamuraiWTF, we do release about almost quarterly. We've run the project for 3.5 years, and we've had 12 to 13 releases currently. So we try to keep the distribution updated very much so. If any of you ever take a SANS class for the web application or their SANS Sec 542, the web pen testing course from SANS, Kevin and myself are actually the lead instructors for those courses at SANS as well. We actually use the SamuraiWTF for that course. We also use the same methodology that we present here inside of the SANS courses. So where are we going with SamuraiWTF? As I mentioned, we've been running for about 3.5 years. We officially launched SamuraiWTF at DEF CON 16, I believe is the one we launched it at. And we've been running ever since then. Currently, it's based on Ubuntu, running a GNOME interface. We are planning on the next release, the 2.0 branch, being able to release it in both KDE and GNOME. So that way you can choose between your desktop interface, which is really funny because Kevin and myself both prefer KDE over GNOME, but yet we've been running it as GNOME only for the last 3.5 years. So we're going to finally fix that and scratch the itch that's been bothering us for the last few years and get KDE in there. Another thing that we're planning on doing is moving over to the KDE build process, the Ubuntu Live DVD build process. We have been using a process called Remaster Sys, for those that have ever used that before. It works fairly well, but Remaster Sys does have some limitations as well as some outstanding bugs, which have been very frustrating to try to work around. So we are going to be migrating over to the Ubuntu build process. Unfortunately, it's a manual process and much more intensive, but we're hoping that we have a better a better distribution and gets rid of some of the bugs that plague us. In fact, as you boot up, everybody's seen the nice retro graphics as you boot. Okay, that's one of the bugs that Remaster Assist decided to totally lose our boot graphics the last time we built the distribution, and unfortunately we failed to catch it in our tests before we released it out to the public. So that will be addressed on the next release, or I should say already has been addressed. The final thing that we hope to do with SamuraiWTF in the future builds is we're hoping to take all the software we have installed and move it from manually installed inside of this distribution to make it into Debian packages. So that way we can update individual packages, hopefully be able to make it much more easy to collaborate on this project, so that if any of you have suggestions or patches for us, you'll be able to grab just the Debian package for the software you're trying to patch. You can submit a patch and we can go ahead and accept that into a distribution. Because right now, the way we're doing it is I will take a turn at building the distribution. I will re-roll the ISO and then send that back up to Kevin or Raul, and they can then download it. They'll make their changes, roll it back up. And so we're passing around this 1.5 gig ISO file and rebuilding it every single time that we're making changes, which is not a very collaborative method to be able to build a distribution. So we are moving towards these software Debian packages. It's just a very time-intensive process to try to get all these packages built. Once I get those packages built, one of my personal goals is to actually take all those Debian packages and actually upload them to as many as we can that licenses are permissive. We'll try to get them inside of the Debian archives repository as well as the Ubuntu repository. So my goal is eventually we'll be able to have Ubuntu or have Debian, any installation of it, and do an apt-get install, whatever tools that you want that come from our distribution, or do an apt-get install SamuraiWTF, have it automatically download all your web pen testing tools. That's my ultimate dream for the project, is be able to have that integration to Debian and Ubuntu. If you're interested about the project, learning more about the project, I do have the project URLs up here. We do have a mailing list. It's a fairly low volume mailing list, so you're not going to be inundated with emails, but it's a very good way to be able to track what's going on in the project as well as to communicate with the developers. And we do have some of the project leads down there at the bottom of the slides. So let's go ahead and take a minute and make sure everybody's up and running with Samurai before we go on much further. So we did pass out those live DVDs in the back. You can have your machine boot directly off those live DVDs to get into the distribution, or once again, start up a virtual machine, tell the virtual machine to boot off the distribution. That will get you up and running. If you're using a virtual machine, my recommendation, do not install it to the virtual machine hardware at this time. After this workshop, feel free to install it. That's probably the best way to use it, is installed inside of a virtual machine. However, for this workshop, just for speed, it's usually just better running it as a live distribution, a live bootable disk. So that way, if there's ever any problems, you can simply shut down your virtual machine, restart the virtual machine, and you have it's reset, basically. So that's the easiest way to use it during the workshops, in my opinion. To do that, if you're using a newer version of VMware Player or VMware Workstation or VMware Fusion, when you go to create a new virtual machine, you actually have to choose the very last option that they give you and tell it you want to create a custom virtual machine. Otherwise, it's going to try to automatically install from the ISO that you point it to or the DVD that you point it to. So I'd recommend creating an empty custom virtual machine, and then after it's been created, then pointing it at the ISO file or pointing at your live DVD to get it running. So far, how many people are up and running inside of SamuraiWTF? Okay, so we have a handful. How many are still trying to actually get up and running? Let me go ahead and take about 5 minutes, walk around and try to answer any questions we have. We have a lot of people in the room. If you are having a hard time, feel free to ask one of your neighbors, look around to see who has it up and running, and let's try to get everybody up and running as fast as we possibly can. Okay, I think we've gotten as many people as we can. If you are still working on getting up and running, feel free to bother your neighbors. I give you permission. All right, it's group effort here. All right, a couple bugs that I wanted to warn you about that's in this current version that you're running right now. We have figured out finally, I think, how to fix some of these bugs. The first bug that we have, well, actually even before that one, when you boot up, everybody sees the beautiful, beautiful boot screen, right? So let me boot my version here so you can see the beautiful boot screen. Oh, there it is. Right? That was on purpose. We wanted the retro look. So, yeah. Well, of course, if we had Samurai on there, you might be able to believe me. But anyway, so yes, we used to have a very beautiful graphic there at the boot screen. If you look at a previous release, this release got broken. So, the other bug that we have is right here. This Ubiquiti GTK.desktop. That's actually the icon that's supposed to stay installed a hard drive. For some reason, Remaster insists on renaming it on us, and we've changed configuration files. We've tried updating Remaster. It's been a bit of a nightmare process. But if you ever want to install this to your hard drive, let's say you boot inside of a virtual machine, and you want to install it to the virtual machine, just double-click on that icon, and it will help you install it. Other pieces of information inside of the distribution, we do have a changelog that we try to keep updated, letting you know what's going on inside the distribution. Wait a minute, which version? Okay, nope, that's right. Thought it said 9.7, 9.9.7, and I was like, wait, did I grab the wrong version to boot? And we do have a README file. If you are ever going to install this to your hard drive and use it as a permanent installation, I do recommend highly that you read through this README file. There are two configurations that I have made in the distribution that might mess you up if you have a permanent installation of this onto a drive. Those two different changes have to do with the security keys for SSH as well as with the Apache web server for the HTTPS. When we have SSH coming up, most of your live distributions will have SSH keys that are static for every single ISO. So if every single person in here was booting off the same exact live DVD and everybody was trying to run an SSH server, you would all be running the same exact SSH keys, which means that everybody's susceptible to man-in-the-middle attacks. So one thing that I've done inside of SamuraiWTF to at least try to defend against this is every single time you boot SamuraiWTF, it regenerates your SSH keys and regenerates your SSL keys for Apache. So everybody is running with different server-side keys to avoid these man-in-the-middle problems. However, this does become problematic when you install this to a physical location because every single time you reboot the machine, it regens those SSH keys, and you try to SSH into the SSH server, and your client says, hey, wait, somebody's trying to hack you. No, I just rebooted my machine. They're very easy to back these two changes out. If you look in the README file, I do tell you where to go look for those README or those changes. We do have credits inside of the README file as well for all the people that's done the graphics. I am not a graphic artist. I did not create the graphics, but we do have people that was very kind to donate their graphical work to the project. All right, so first off, the login screen. If you have the login screen, for some it should automatically boot in or automatically log in. For others, it will not. If you ever see the login screen, the password and username and password is Samurai. If you forget, we do have a website you can go to. What's the SamuraiPassword.com, and it will tell you what the Samurai password is. If you can't remember the password, I guarantee you will not remember the website. However, it is the #1 support question that we have on the Samurai Project. We have it posted all over the Samurai Project's website. We have it inside of the emailing archives. We have it inside of the README file on the desktop. We even have it on the boot screen. If you look right there underneath where it says Samurai, it doesn't render quite right on the projector. But right here, it actually tells you what the password is, username and password. So, everybody now knows the password. If you use sudo, the password is... You guys get it? Samurai. Okay, once again, that's the desktop. We have several different tools in there. If you go through and look at the drop-down menus, so inside the distribution, okay, you go to Applications, Samurai. We have all the tools broken down into an organization based on our methodology that we teach. So we teach a 4-step methodology: reconnaissance, mapping, discovery, and exploitation. So you'll find the tools located in whatever section that you would most likely use it inside of the methodology. So these are the reconnaissance and mapping tools, the different discovery tools we have, and the different exploitation tools we have. This is not all the tools. These are the more common tools that we have. We have tools stashed in lots of different places inside of the distribution. So besides having inside of the main menus, we do have a lot of Firefox extensions as well. Of course, those are only going to be found inside of Firefox if you open Firefox up. And they will try to automatically update. Okay, so once again, all the various different extensions to Firefox are available there. Besides the Firefox extensions, we do have several different web application tools available inside of Samurai. We have links inside of our bookmarks inside of Firefox. We also have a landing page as well. So if you go inside of your distribution to localhost, you will find all the different Samurai tools that are web-based installed. We also have several different vulnerable web applications to be able to test your tools against. One thing as a penetration tester is you should never be using a tool against a production application unless you are familiar with the pros and cons of that tool. So we actually build some vulnerable applications right in so you can actually test your tools. This works very well for educational purposes as well. If you're trying to learn application pen testing, they give us some very, very good, simple targets to start with to be able to practice our skills on. So we're going to be using some of these different vulnerable web applications today. Specifically, we'll be using Matilde and DVWA for our tests today. So they're very simple applications. They're very easy to grasp the concepts that we're going to be trying to describe. We do have other tools that are in there for WebGoat, for those that have never messed with WebGoat, as well as a couple other different vulnerable web applications to play with. And then finally, the last set of places where you can always look for our stashed tools is inside of our directory structure, where we actually literally install the binaries in the applications. This is going to be inside of User Bin Samurai. So inside of User Bin Samurai, there's a separate folder for each tool. Most of our command line tools are not in the Linux path, which means when you want to run those tools, you have to be in the right folder to run it. And you have to put a ./ in front of it to execute the command. So always try to remember to do that. If you start any of the command line tools from the main menu, it will automatically move you to the right location. If you choose to start them just from the command line, make sure you manually change to the right direction. One of the goals that we do have for the 2.0 branch that we are just barely starting now inside of Samurai is we would like to try to get the majority of these tools inside of the path. Some of the tools are a bit problematic because the way that they have been written and developed, they have a very hard time trying to find their libraries. So we're going to have to fix those tools. We're going to have to be doing updates and patches to those tools ourselves to get them to work. Okay, so let's go ahead and very briefly dive right into our testing methodology. I'm going to skip that first slide. Let's go to just the four-step methodology we have. So we teach reconnaissance, mapping, discovery, exploitation. So just like in all penetration testing, we do talk about reconnaissance. Reconnaissance in such that we're learning about the targets that we're testing by using resources that are freely available online. Okay, so really we want to use sources like Google hacking, use information that Google can find for us, use social network sites for us, use mailing lists, use forums, use Google groups, use any type of resources we have online. When we're using reconnaissance, we're looking for different types of information about our targets, the companies that we're going to be doing the penetration testing on, the application we're testing on, as well as the developers that wrote the application and the users that use the application. So we're looking for different pieces of information, possibly like a developer going out and seeking help for his coding style and saying, hey, this one little snippet of code's not working for me. Can somebody help me fix this one single problem? And in the process, they might actually post code from the application that you're testing and be able to find right inside of the code, hey, look, we have vulnerabilities right here in the code. Or these are live examples that we find all the time. We've seen code snippets from developers working on an application we're testing, and because I did reconnaissance, I tripped across the mailing list from this developer, and I can see right in the code snippet, I have SQL injection and cross-site scripting in this little snippet of code he's asking people to help him with. And boom, now I have my first two findings without ever visiting the application. We've literally found, in our reconnaissance exercises, we've literally found places where developers would do the same thing, put code snippets in there, and they would totally forget that the code snippet included the connection string to the database, which included the username and the password and the internal IP address to the database. So when we're doing reconnaissance, these are the types of things we're looking for. Not only the explicit vulnerabilities, but we're also looking for things that are a little bit more, not necessarily vulnerabilities, but information we could use later on when we're doing exploitation. For instance, we will try to learn about the users that are using this application, especially if the application has a password reset or password recovery feature and ask personal questions. Go use the social network sites and research the users of this application and get this information about their personal likes and their personal dislikes. So when they ask you what their favorite sports team is and their favorite sport, you'll be able to find their MySpace page, notice, right, hey, this is a MySpace page dedicated to this individual's favorite sports team, and go to those password reset questions and guess properly the very first 2 attempts that you have, be able to guess what their favorite sport was and their favorite sports team, because we found it on their MySpace page or their Facebook page or their LinkedIn page, or find their birthdays off of those pages, which is commonly used to be able to answer some of the questions as well. So that's what we're using the reconnaissance step for. After we've done reconnaissance to learn about the information for this company and the target that's leaked out to the internet, we then want to start mapping the application. When we do mapping of an application, we're learning about our target. We're learning about the different ways that the application has been built by the developer. We're trying to learn about it from 2 different perspectives, is the way I like to describe it best. I'm trying to learn about the application from the user's perspective, how a normal user uses it, what functionality is there for a user to see and to use. At the same time, I'm trying to learn about it from the developer's perspective as well. How has the developer organized the different pages of this application? How is he accepting the input? What is he doing with that input? How is he sending it? How is this related to different backend services that are being called? Trying to understand as much about the application as I possibly can. During the mapping phase, we're not sending any malicious traffic to the application. All we are doing to this application is we're trying to learn about this application and learn how it's been built. Once we understand the application, we understand where all the functionality is, we've had a chance to visit all those pages and better yet, have our interception proxy or whatever tool we're using capture recorded requests and responses, so we have a history of all these interaction with the application. Once I have that information, then I want to move to the next step of the methodology, which is discovery, looking for the vulnerabilities, looking for the flaws in the application. On the discovery part of the methodology, this is the very first time that we're sending malicious requests to the application, trying to cause events to happen in the application to give me differences in the way the application's acting. Okay, trying to do this. This is where we're doing fuzzing. We send a lot of automated tools in this process to automatically find vulnerabilities. We'll use semi-automated tools to go through and do it, as well as going through and manually checking some of the more likely vulnerabilities and some of the more likely areas that we can see that, hey, this is something that may be very applicable here. Once we have gone through and discovered many vulnerabilities in the application, then we move to exploitation. One of the biggest mistakes penetration testers make the very first time they start testing web applications is as soon as they find a vulnerability, they try to exploit it. The problem is some vulnerabilities are very, very difficult and sometimes not even possible to exploit. And so if you spend a lot of time trying to exploit the very first vulnerability you find, then you are wasting your time and not being efficient. I don't know about you, but every time I've ever done a penetration test, I have a very limited scope and a very limited amount of time to be able to perform that work. So go through and find all the vulnerabilities first. Once you've found the vulnerabilities, then look at the vulnerabilities and determine which of the vulnerabilities are going to be the easiest to exploit or pose the greatest risk to the organization, and organize which vulnerabilities you want to try to exploit first. Then systematically go through and try to exploit the vulnerabilities that you find. If you exploit a vulnerability, quite often that vulnerability is going to then introduce you to more information you can gather. You might be able to find a portion of the application you weren't able to previously access. At that point, then we want to move back to the beginning of our methodology. Ask yourself very briefly, is there anything I should go and search for online in Google and the social network sites that would aid me for this new portion of the application I recently discovered because of my exploitation? Sometimes there is, sometimes there isn't. Okay, But regardless, there's almost always something to go back and map. So we map some more application, we do some more discovery of the new portions of the application we haven't seen before, and we go through in this very cylindrical process. This is the goal that we're always trying to reach. In reality, this is what it really looks like if we be very honest with ourselves. Now, while this is what it really looks like, this is what we should always be striving for. Okay? A very, very consistent process through. However, I admit that if we're going through and I find that code snippet from the developer that has the SQL injection and the cross-site scripting on the web forum that he had posted it on, I admit the very first thing I do is that a code still applicable to my application? And I would immediately go and actually try it to see if that's valid. So you do jump around the process. However, in order to try to control this, I have a personal rule of thumb that I use to try to make sure that this doesn't get out of hand and that I don't lose scope of my assessment. I use the rule 5 attempts or 5 minutes. Okay, if I ever find something that I want to step outside of my methodology for, I try to make a very conscious decision. Hey, I'm in the mapping phase right now. I want to jump to exploitation. Okay, in order to jump to exploitation, I'm going to give myself 5 attempts or 5 minutes to try to do this. I will literally look at my clock. Okay, see what time it is, mark in my head, okay, this is the time I have to stop. I will then go ahead and play for 5 minutes. If I can't do it in 5 minutes, I immediately stop, write down exactly what I've done, what I should continue to try doing, and then go right back to where I left off in my methodology. Okay, so that's the rule of thumb that I personally use to keep myself on track, because otherwise you get too wrapped up in the application and you end up totally forgetting about time and scope goes out the window. So. All right, now we're just going through, so you can read through those. Those are just basically exploitation or descriptions of the different vulnerabilities you're looking for, as well as details on we're going to jump all the way up to our first target. Okay, so the first thing we're going to be playing with is an application called Matilde. This is a very simple application. It was written by an individual, Andre, some of you guys know him, goes by the name of Iron Geek, also a website many of you guys have probably visited before. This is a vulnerable web application that's written in PHP using a MySQL backend. He wrote this application to be able to go through and portray the top 10 vulnerabilities to OWASP. He does use the older top 10, the one from 2007 or 2008. This is not the current version of the top 10 vulnerabilities. This tool hasn't been updated since then, but still a very, very applicable tool going through and giving us a very simple application to be able to test and find some of these vulnerabilities on. Inside of Samurai, in order to get to Matilde, if you open up any browser and just go to http://Matilde, that will get you right to the Matilde application. It does have some built-in users and passwords already in there, but it has a registration screen that you can go through and register on your own users, and we'll go through and we'll do that. It has a hint system, so if you're trying to play with this application, you can turn on hints and be able to see, hey, look at this vulnerability. Here's a hint on what you can do to try to exploit this vulnerability. So for the workshop, this is our brief testing plan that we're going to go over to try to perform a penetration test on this application. This application is very, very explicit in telling us right where the vulnerabilities are. We're going to pretend like the application doesn't tell us that information. We're going to treat this as a normal application that we would test in the course of our normal jobs. Okay, so we're going to go through the methodology. We're going to skip reconnaissance only because, number one, most of us may not have internet, and number two, because we're testing a fictional application. There's not real developers and real companies behind this. So the information that we'd be able to find in reconnaissance is very, very limited. So we'll jump straight into mapping. So we'll go through, we'll open up Firefox. We'll talk very briefly about the different Firefox tools that we have available built into Firefox. We'll go through some of the different Firefox extensions, be able to play with the application, and then talk about some of the different exploitation tools that we have available to us. We won't go through and hit all of these, but I'll try to hit some highlights for us inside of as we're going and doing and testing this. So we'll probably end up using Matilde up until the coffee break. Then we'll take a coffee break. We'll come back. We'll continue with Matilde until about halfway through the second session, and then hopefully somewhere in the middle of the second session we'll migrate to DVWA, the second application that we're testing, and start getting into some of the other tools that we have available to us. Okay, and please forgive me if we're going too fast. I just want to make sure we get through as much content as we possibly can. I will be available during the coffee breaks as well as after the workshop if anybody has any questions. Okay, so we're going to be using Firefox to be able to play with this application. Very briefly, there's a couple tools built into Firefox that I think a lot of people don't use or maybe aren't aware of how they can use in penetration testing. Some very basic things that we have. So the page info, the error console, the DOM inspector, and the view page source. Most of us have done view page source. That shouldn't be new to anybody. But the one that I want to pull out of here real fast is probably the page info. There's some good information on page info that will help people in their penetration tests. So if I look inside of Firefox and I do Firefox over to Matilde, okay, so here's the Matilde application. Anytime that I'm looking on a page itself, we have these built-in Firefox. These are not extensions; they're a part of Firefox itself. But if you come down to page info, okay, it tells you some information about this application. Some of the more interesting things about this page info is it does tell you the size of the page that we're dealing with. It tells you how it's been encoded, and right here, if you look, it tells you the last time that page has been modified. Okay, and what's unique about that date that we're seeing right there? What was that? What was that? Yes, this is an old application. Okay, but what's that date telling us right there? It's today's date. Why is it today's date? No, not JavaScript modifying it. Because this page was generated for us. Okay, when we're dealing with web applications, one of the first things we have, it's very essential that we understand, is that some content on a page is static in nature. Some content is dynamic in nature. In order to tell if something's static or dynamic in nature, look at the modification date. If the modification date is current, we know that it's been dynamically generated by that web server application on the back end. However, if we grab something that is not dynamically generated, most of your images are not dynamically generated. So let's go through and do view image. Okay, grab the tools to page info. Now check out that modification date. Now we see it's from 2009. This was a static element. It's not dynamically being generated, so we actually see an older date there. Okay, the reason why this is important is this will actually help us in our penetration test, not only to decide what static images are or static content is and dynamic content, but also to go through some of our various different testing. One of the things that we test as a penetration tester is if we're ever going up against an application and this web application we're testing has a cluster of different servers that are being served up. One of the things I want to do as a penetration tester is to try to identify how many different servers are inside of this cluster. Okay, there's a number of different ways to do it. There's about 7 different methods you could do to determine this. One of the methods is to find a static element on the application, okay, and make requests for that same exact static element 100 times, 150 times. Using no cookies, using no session variables, just approaching this application uniquely as if you were a first-time user 100 different times. If the load balancer keeps on sending you, depending on how load balancer is configured, it may or may not send you around the cluster, but if you are making those requests without the cookie and the load balancer is configured such to keep on sending you to new servers in the cluster, depending on how they copy those files over, you're going to see different timestamps for each of the static elements. Okay, so that's one way you can fingerprint how many different machines are inside of a cluster hiding behind a load balancer. Okay, so look for these different elements between static and dynamic pages. Okay, so that's just kind of a fun little tool, page info that has some useful information inside of it. So it does have some other information. If you ever want to see the elements on a page itself, you can go straight to the media page to show you all the different elements. This is just one single graphic, but if I come back here, one thing that we'll sometimes do is we'll try and identify where the different media elements are on the page, and sometimes if I'm not thinking clearly, I'll open up and try to just dig through the source code trying to find it. Okay, that always works, digging through the source code. But if there's a lot of source code there, you just open up the page info, and it will actually pull that information right out for you. Okay, so we can see the different media elements inside of the pages. Okay, you can also go through and see the dependencies to see where other elements are being pulled from this page. So just very, very simple information that's available to us. It's something that many of us simply don't really know it's there inside of that page info application. We do have access to the DOM inspector if you ever want to see what your DOM is. This used to be included inside of Firefox, but they've now removed that and has it a separate extension from the Mozilla Foundation. But you can go through and see your document object model, surf through the different elements of it. The DOM extension does allow you to go through and do searches. It allows you to go through, let's say if we wanted to search, actually this doesn't have a form on this page. If I get to something with a form like the register page, I can go into my DOM inspector. I can do a search, for a tag. For a form tag, so I can immediately jump right to the section in the DOM where the post variable is. I can come right inside of it, and instead of having, hey, this is a form that does a post method, you can come right in here and actually change it to a get method. So it's kind of a fun little tool if you ever need to interact directly with the DOM or the elements inside of the page. Okay, so a very simple application. Let's see, other elements. Anything else I want to call out from the others? Everybody knows how to view page, right? View page source is nothing new. Right-click anywhere on the page or under your edit menu. You will find view page source. If I'm not interested in viewing everything, you can just go through and highlight what you're interested in seeing, right-click on it, and tell it we want to view source selection. So if you want to just focus right into that menu to see where each of those links go to. Okay, these are things that shouldn't be new to most of you. All right, some of the other Firefox extensions we have. We have Firefox extensions tamper data. Of course, it doesn't help when I unplug the projector. There we go. So Firebug, the user agent switcher, add and edit cookies. So we'll go through. Inside of SamuraiWTF, we have many different extensions installed. If anybody is interested in getting a concise list of all the extensions, install them inside of your own Firefox browsers on your own desktops, we do have a Firefox collection available for it. If you go to the Firefox add-on page, there's a link for collections. Search through the collections and find the one for SamuraiWTF. We do have a link at the very bottom of this slide. So if you go to this URL, you'll actually find the collection and the list of all the different Firefox extensions we have installed inside of SamuraiWTF. So this will allow you to pinpoint exactly the extensions you may want to install and to play around with inside of your machines. So we're going to go through and play with a couple of these. So tamper data is going to be the first one. We're not going to be using it to intercept requests. How many in here has played with tamper data? It's one that many people have played with. Oh, okay. Not as many people today for some reason. Let's, what we're going to be using, we're going to be using tamper data for our mapping part of the process of the application. And then we'll also go back and use tamper data a little bit later on while we're trying to do discovery and finding the vulnerabilities in our applications. So I'm going to go into Tools, go down to Tamper Data. We're going to open up Tamper Data. And I'm going to maximize that window, and then I'll just switch back and forth between it. I am not going to hit the Start Tamper button. Okay? Tamper Data has a lot more capabilities than simply being able to intercept our requests. So we're going to use Tamper Data basically to record everything that I'm visiting inside of this application. So with Tamper Data open, I'm going to go through and do a manual mapping of the application. So as we're mapping application, once again, the things that we're looking for is we are trying to understand all the functionality that is exposed to the user. We're also trying to understand how the developer has put this code together and try to look at the code samples of what we can see and try to make some guesses and hypotheses about how the application works in the background. Okay, so as soon as I visit one of the pages, let's visit the home page first. Look inside of Tamper Data, and let's make sure that we actually see some data inside of Tamper Data. So there's the home page. So you can double click on any of these elements and see exactly the URL that was requested or copy that back out. You can see down here that this is all the information that was used to make the request, and here's the response that came back to us inside of Tamper Data. So what I'm going to do is just go through and manually map this application. Whenever I look at an application during a penetration test, I want to, during my mapper exercise, very quickly navigate through the application to learn about what the application has. Try to visit every single piece of functionality that I have in the application. So here's, I'm reading through the application, I can see a lot of these links. If I do mouse overs to these links, the very bottom of the window will show me that that link goes to irongeek.com. And if my scope is just the Matilda application, then I have no need to visit that link. It's out of scope. So I'm not going to worry about it. Mouse over that one. Yep, that's external. It goes to OWASP. That goes to OWASP. That goes to OWASP. Okay, these all go to other locations. So none of this information is, none of these links are actually linking back to the application itself. They're all external links. Another thing I do in my mapping exercise is, at least on the home page, I will thoroughly read through everything on the home page, because a lot of time there's text inside of these pages that give us contextual information to the application. They help us understand the application. So I'll read through the home page. I'll also selectively read through other pages throughout the application. I don't try to read everything, but you want to try to get an understanding of what's going on in the application. So we have to do some reading. All right, go to the next link inside of the menu. Here's a registration account. So create an account. Let's go ahead and create an account for ourselves. Justin, or whatever you choose for your username. Password, I hate long passwords. I hate long passwords. Okay, whenever you are creating accounts or changing passwords or doing things on the application, always stop and remind yourself, hey, I am testing this application for flaws. You don't want to introduce new flaws. If I was to choose the easy way out and set the password to password, I'm creating a flaw in the application, a weak password that can be exploited. And yes, we have had times where somebody's exploited applications while we've been performing penetration tests. So you want to be very conscious of that anytime that you are doing your exploitation or changing things, try to use decent, sane setups. In fact, it's absolutely hilarious if you change somebody's password and then they come, and we had one user one time that we had reset his password. And when we reset the password, we set it to a 24-character password. That was a nice passphrase, very, very easy to remember. And he complained because it was so long to type. So, you know, I don't know what he wanted to set it to password, something very easy that anybody could guess. So don't create vulnerabilities. Inside of this application, sometimes we're going to have fields which we don't know how it's used in the application. For instance, username and password, we can all know exactly how that's used in this application. However, when we get to signature, I don't know how this application is going to use a signature. So quite often when I get to fields like this, I'll just simply put in something that will help me remember what this field was, where this input is. So I'll put something like, hey, this is my signature. So that way, when I see that text, I'll remember right where I put that information into the input form. Okay, go ahead and tell it submit, and then of course, that's the problem with typing long passwords, right? There we go. Account has been made. And well, one more page before we, we did that register page. Let's go look at inside of tamper data. So here's the request that I've been making. So there's the very first request I made on the home page. Then I went to visit the register page. Okay, on that register page, if I look right here, no, that's not the one. That's not the one, except for that's nice to see. There we go. Okay, so in tamper data, I can see that I made a GET request to this register.php page. Okay, so here's all the requests down here that was made. And then the next request was a POST request to that page itself. So the first one was getting the form. The second one, that POST, was actually submitting the form. And if I look down on the bottom left-hand corner, I can see that when I do the POST, there's additional information down there and this POST data. So this is the information I tried registering with. And if you all noticed that when I registered the password, it failed that first time because the passwords didn't match. Okay, there's the two passwords I used. So as I was talking to you, I totally buggered up my password both times. very horribly. Okay, so then I had to revisit that page because it didn't match, and then I resubmitted the post. And you can see right here, now I actually properly typed those 2 passwords correctly as input to the application. So we can use tamper data to record everything we did inside of our application. Okay, and then we went to the login page, delete the login page, and at that we'll go ahead and we'll stop for our coffee break. We will meet back up in 15 minutes, and we will continue this exercise as well as play around with some of the other tools. So just to recap where we're at. So we've gone through, we're right in the middle of mapping the exercise. As we're mapping the exercise, we're trying to learn about the functionality of the application that's being exposed to the user, as well as trying to understand a little bit more from the developer's perspective as well. Specifically, these are some of the questions that I ask myself as I'm mapping an application. Okay, so when I'm doing this mapping exercise, I stop and I ask myself, does this application have some type of a login or logout feature? Because these are things I want to explore and play with. Okay, if it does have a login logout feature, I want to ask myself, how does it track session state? Because once I log into the application, it has to have some mechanism in the browser to track whether I'm still logged in or not. So I want to try to identify that in the application. I want to try to identify if there is a login concept. Are there different ways to change user settings? Are there different ways to reset the account or recover my password if I forgot my password? Because quite often when you're dealing with logins, it's the reset and the recovery pages which have some of the worst vulnerabilities and the worst weaknesses to it. Many times developers have very good login pages because we stress the importance of that login page. However, quite often as security professionals, we either fail to test or fail to emphasize the importance of these reset and these recovery pages. Other questions I want to ask myself as I'm going through and doing this mapping exercise is which different inputs are being reflected back to the user themselves. When I enter something in to an application, okay, what information that I'm entering is being reflected back to me? Because these are different things that we could exploit for cross-site scripting. We also want to try to identify, are there any inputs that appear to be being used as part of queries to the database or entered into a database? Because these are different things that we could actually test for SQL injection. We can also pay attention to different type of timing elements of when pages are requested and how long they get processed. If we ever have a request to an application that consistently takes a long time to process, that's actually a very, very good a request to target if you're ever trying to test for denial of service type flaws. Because the reason why it takes a long time to process may be because it actually has to deal with some back-end processes or other external servers on the back end. Or it may be a database connection, a SQL connection query that is very, very complex query and takes a lot of resources to run that query. So anything that takes a long time to process are things that we want to check to see if they're vulnerable to different types of denial of service type requests. So right back to where we left off, we were playing around with Matilde, mapping the Matilde application. We have registered a user, and then we're looking at those registered user pages. And then we're going to start looking at that PHP, the login page. Before we go any further, I want everybody to notice that since we've been gone, I did have a couple other pages pop up inside of here. Okay. Firefox and most of your browsers will automatically make some requests in the background. Here I can actually see it making requests to FX feeds and safe browsing in the background here. In order to get that out of this view so I don't have to see it, go up to the filter and you can type Matilde in the filter, and that will filter out all those extra requests so I can only focus on my in-scope application that I'm dealing with. Okay, back to Firefox. So here's my Matilde application. I've already registered a user. Now the next thing I want to do is I want to try this login form. So in this login form, go ahead and put my username and password that I put in there. So Justin. And my password, I hate... Okay, I'm going to not talk because I typo it every time when I'm trying to speak it out loud. So I hate long passwords is my password. I'm going to hit submit. And now I'm logged in. First thing that I notice is that I am logged in. Here's my name, Justin, coming back to me. Where did it get this input? This is not built into the application, right? This is something I programmed in. Where did this come from? It came from a SQL query, okay? But initially, this is something I entered in, right, when I registered the user, okay? So this is input that's being reflected back to me. Some of the input like this is actually something that most of your automated vulnerability scanners have a very, very hard time trying to detect. The reason why is in many circumstances, the input, which it got this logged in user from that register page, is a totally different page than where it's being reflected back to me. Most of your automated applications, when they're actually fuzzing for inputs and fuzzing for vulnerabilities, they'll actually fuzz for SQL injection or cross-site scripting right on that first request. But if the immediate response that comes back isn't the validation for that, or doesn't show that cross-site scripting attempt, if it's some other page on the application, most of your automated scanners are very, very poor at trying to find those. So as a penetration tester, I always want to try to identify any time that I'm seeing something reflected back to me that I entered in sometime during the process. Okay, when I see things like this, generally what you want to do is you want to start writing these down and keeping track of it. So I can come in here and open up a text editor and start making notes to myself. Okay, requests to test for XSS. These are the things that are actually reflecting information back to me. Okay, so the register page, username reflected back post after login. Okay, so I'm just making a note to myself, hey, this is something I can test for cross-site scripting. Oops. Go back to my application. Okay, now another thing, notice right here, this is my signature. That was also something from the register page. We now know where it is. That's why I like putting things in here that are self-reflective back to where I put them in. This is my signature. Now I know exactly where it came from. Of course, it's very annoying as well that it's flashing at me. Okay, so the register username and signature. And you can even put in header. Okay, so that's something I should check for SQL inject or for cross-site scripting. I'm not testing now for cross-site scripting. All I'm doing is I'm mapping the application and noticing these different elements that I want to test later on, so keeping track of those. Okay, so that was the login page. Let's immediately go back to tamper data and actually see what happened during that login process. So here's the login page. I can see the GET request that obtained the page itself, the form, asking me for the username and password. Then I can see my post request, which is where I logged in. I can see my post data right here, that the username I entered in was Justin, the password was I hate long passwords, and the submit button was, of course, the submit action that when you click on that button itself. Okay, so this is what I submitted when I logged into the application. If I look over here, on the response when I logged in, I see a set cookie value set to 5. Okay, this is the most common way that applications actually track that you've been logged into the application is by setting a cookie variable. Okay, a session variable set as a cookie. So I can see that the session ID is set to 5. Okay, and when I look at that, that should actually raise some red flags for anybody that's messed with session variables before. What's wrong with that session variable? It doesn't look very random. The number 5, a single digit, that's not even close to random. We like seeing random, non-predictable session variables because if it's something that is predictable, I can exploit that as an attacker. Okay, so we're just sitting there looking at this, trying to learn more about this application. So what we need to do is come in here, make a little note to ourselves. Okay, session variable looks predictable. And from note to myself, UID equals 5. It was a set cookie. UID is equal to 5 is how they're actually tracking it. Now I have my little note that, hey, when I get to discovery, let's go ahead and check that out. Once again, I'm not really looking for vulnerabilities now. I'm simply trying to understand how the application works. And in that process, I'm checking things that look like vulnerabilities. I'll try to validate them a little bit later. All right, let's go back to the application. Let's try the logout page. Anytime I log in, I like to test the logout page right then, or at least look at it. Okay, so now I've logged out. Notice it says not logged in. It's low. It lost the really horrible flashing stuff that we had up there. Let's go look at our tamper data. So we can see, let's see, there was the login. After we logged in, it automatically dropped us to the home page. And then on the home page, it went through and automatically grabbed the favicon. And then after I was on that home page, I personally clicked on the logout page. When I clicked on that logout page, it was just a normal GET request, nothing really special about it. Notice that every single time since I've logged in, it always has that cookie UID is equal 5, so that's how it knows that I'm currently logged into the application. I hit the logout page, and in the response on the logout page, it sends me a set cookie of UID is equal to deleted. Okay, so it's actually deleting that session variable. So that's good. We like seeing that. We like seeing that the application is expiring our session variable because now I'm no longer logged into the application. All right, let's go back to the application. Let's log back in. Since I logged myself out, Justin, I hate long passwords. Okay, we can look at other functionality. We can toggle hints. Oops. That toggle hints actually is something that doesn't really help do us very much. It helps show you some of the hints, but for our purposes in the page, we don't really care for it. See, there's our hints right there. We're actually going to turn that off because that toggle hints actually ends up causing false positives when we play with it with some of our other tools. Okay, we do have this other functionality of set up and reset the database. This is something that would be a sensitive request, something that I probably do not want to turn on if I ever have automated tools running. So I would say toggle hints, since that talks about cross-site scripting and SQL injection, that might cause a false positive to my automated tools. So that's something I want to tell my automated tools to stay away from. And I want to tell my tools to stay away from setting up and resetting the database, because that's not a normal functionality inside of an application, and that might throw off consistency in my automated tools. If they start testing the application, then they reset the database and all of a sudden lose the user that they were using. Okay, it could cause havoc for my automated tools. So once again, in my little notes that I'm keeping for later on, okay, so automated tools, blacklist following. So I want to blacklist the toggle hints. I want to blacklist the reset database. And also usually want to blacklist the logout page as well. A lot of your automated tools automatically try to detect the logout page and will avoid it. But those are just some notes that I'm making to myself once again as I'm learning about the application. Okay, I won't even go to setup and if you go to that page, you'll have to go back and register a user. So I'm just going to skip that page. Okay, we have a show log. It goes through and shows me all sorts of information about the previous people that's made requests to this application. This is something, while you may not explicitly find in many servers that are out there, quite often, especially if it's an internal server not exposed to the internet, you will find elements that may show you some of the previous requests that have been made in the application. If you ever find anything like this, this is an immediate vulnerability. We never want to see previous requests to the application, because quite often those previous requests will reveal sensitive information about the application. They may reveal sections of the application which you can only access once you've logged into the application, or sometimes they may even reveal the username and password if those usernames and passwords are being passed incorrectly inside of an application. So that's something that we can note down. And then of course there's the credits page. Nothing much there on the credits page, talking about various people that's helped out. There was Adrian, or Iron Geek, that created the project, and some of the other projects, all external links, so no issues there. All right, now let's look at the function proper here. Start looking at this page. So here's add something to my blog. Let's give myself a blog entry. Okay, so hello world. That's my. You gotta always enter hello world, right? It's easy to type, very short. So there's my blog entry. It seemed to work just fine. Well, that's great. I'm not testing for flaws now, but one thing I always test when I test inputs like this is I'm always curious if HTML works. So I can do hello world Okay. BR, this is a test. Okay, so just use a carriage return tag from HTML just to see if that works. And yes, we can see that it did actually return that down to a new line and not explicitly show it. So we know that it is accepting HTML. So most likely this is probably something we should be testing for cross-site scripting, this add to your blog. So flip back over to my notes. Request to test for cross-site scripting. Let's do the add to blog page is something I should test for cross-site scripting. There's only one entry, so I won't worry about trying to specify the parameter because that's easy to find. Okay, we're also going to go through and once again, we looked at it from the user's perspective, look at the developer's perspective, look at the actual raw requests that are going back and forth. There was the toggle hints. When we were playing with toggle hints, notice that the way they were keeping track of the hints is with a set cookie value. So once again, just another cookie variable that was using to track the hints themselves. So now my cookie actually says UID equals 5, show hints equals 1, or once I turn it off, you'll see show hints is equal to 0. So that's how the application keeps track of whether the hints are turned on or not. The credits page was just a normal get, nothing special there. Here was the get of the add to your blog page. This is just getting the form. And then we're actually filling out the form here. And we can see my post input for the information I submitted. That was the first time where I did a hello world. Here's the second time that I did the hello world. Whoops. Where I did the hello world with the carriage return. This is a test. Okay, so I'm just looking at the application. Another thing to notice about this application as we're going through it is look at the way that this application has been set up. Every single one of the requests that we're making is all landing on one single PHP page. They're all landing on this index.php page, and each of the different page views that I'm seeing are different parameters being passed to the page variable to this index.php page. So this is one of the many different architectural models that developers use when they build their applications. Okay, so this is more of a home page or an index page architecture where everything's based off of that one single page. Sometimes some architectures, every single page you visit is going to be a unique PHP script or ASP script or JSP script page, and you'll see the names, the resource names changing for every page you visit. Or sometimes you're going to see more of an MVP architecture, which is more of an advanced programming language or programming style, where each of the requests that you make most likely don't reference actual pages on the backend web server at all. They're actually parameter names and values that are being passed and evaluated by the application by pages of source pages that you can't actually see where they're located at. So several different architectural models. As we're mapping the application, you want to try to just look at that and try to make that into your head. This is how this application's been programmed. Okay, let's go back to my application. Let's go to the next one. View somebody's log. So inside of view somebody's log, let's see, I'm logged in as Justin. So I can test that, yes, I've been able to see all my log entries just fine there. I can also go through and look for other people's blog entries, see the information that they've put down inside of those blog entries. Okay, and I can see all users here as well to show everybody's blog posts. Now what's interesting to me is when I click down on this, notice it's showing me all these different names. Okay, to me, this immediately screams out that, hey, I now have a list of every single person that's on this server. I can see each of the person's names on here. In fact, something that's also a little bit more interesting, if you go back and you correlate to what we saw about that session ID and the session variable. Remember what session ID variable we had? 5. What user am I in according to this list? User number 5. Kind of odd, huh? How that happens. So these are just different things that I start correlating in my head as I'm mapping an application. If I see something that's predictable session variables, you know, can I see how that correlates to anything else inside of the application? This is a very simple application. So these correlations are very, very apparent. But even in complex applications, you'll find these correlations that may not be as apparent, but you'll find them if you look for them and try to understand how the application's working themselves. But right here, to me, this is a bit of a concern because not only is Justin what my name is, okay, but it's my username to this application. Remember when I registered my user, I didn't have a nickname or a full name or anything else in there. All it asked me for was my username and my password. So I know that, at least for me, that's my real actual username. All the rest of these users, I can assume that that's their real username as well, since the application didn't give me any other parameters to fill in. So this is actually a vulnerability that we just found in our mapping, which is called username harvesting. This application immediately dropped the whole list of all the users that are in there. And as penetration testers, we always want to try to get a list of all the usernames, try to find a way to get a list of all the usernames, because that's half of the authentication. If we have the usernames, now I can start trying to guess the passwords for the individuals. So I'll come over to my notes, come down to my findings section. So we'll actually separate that off into a totally different section. And these are going to be my findings. The other things above it are more of things to test for. So we want to say that was on view somebody else's blog. How did they term that? View someone's blog. Okay, so it's susceptible to username harvesting. So I'm starting to keep track of my vulnerabilities. In fact, every single time I keep track of my vulnerabilities, another thing that is a very, very good practice is try to always mark down what your immediate impression is for its level of vulnerability, or its level of criticality. You can change it, and you probably will change it once you get to your report, depending on other types of things that we're finding in the application. But it's always nice to immediately put something down. Let's say that, okay, I think that's going to be a medium level vulnerability. Okay, just kind of off my hip guess at that point. We can evaluate it later when you get to when you do your final test. All right. Look at my browser info. There's some information about my browser. Great. It's letting me know exactly where my browser is coming from. Then we can go down to my user info, view some information about your user. My name's Justin, password. I hate long passwords. And now I have this information being reflected back to me in the database. Okay, does anybody have any problems or concerns about anything here that we're seeing? Couple problems, right? How does it know that? Should our applications ever know our password? How should they store them? Hash variables, and not just hashed. We always have to be very careful. We have to say salted hashes, right? Because if you just say hash, people will make the mistake and do it the wrong way. So always say salted hashes is what we want to say. So the application should never be able to reconstitute my original password. Look for this in the password reset. If you ever have to reset your password, you know, there's that function. Try clicking on that reset function to see if they email your real password, or if they give you a random one. If they email your real one, they're storing it the wrong way. Okay, so once again, another vulnerability we have here. Okay, I would say that this is a high vulnerability. Stores actual password shown in, and what was it? Use show in for the page is called view your details. Okay, so once again, notice my notes, very, very short and concise, succinct. I have the information that's necessary, so that way when I go to build my report or continue on my test, I know I have a list of things I can start checking. I'm not worrying about trying to document everything right now, but I'm trying to at least jot some notes down for myself to keep me on track, keep me organized. And also to note that all this information is being reflected back to me here as well. This is all information I submitted on the register page, so you can add that to your list of pages to check for cross-site scripting. Okay, so you can do view my info page, shows username, pass, and signature. Okay, other pages. Notice that how this application has links that we've already visited. This is very, very true in a lot of the applications that are out there, that as you're testing your page, your browser will start marking, hey, you've already visited this link. Even though you're on a totally different section of the website, some of those pages go back to pages you've already visited on. Take advantage of that while you're doing your manual assessments and look at the pages you visited. Okay, so I visited these pages, so I know I don't have to go back and revisit those pages because the browser's already telling me, hey, you've seen these. So let's look at the DNS lookup. In here, let's do a DNS lookup. Give me an IP address or a host name. Well, let's try localhost. So there's localhost, comes back up, gives me some information. Now, this is something that I also find rather interesting, okay, as I'm mapping the application. These are all things that I'm still not looking for vulnerabilities. I just learning the application, but these are things that just pop into my head. What does that output look like? It looks, from what command? It looks exactly like NSLOOKUP. Okay, so anytime I see something like that, I'm going to come over my little notes. Command injection. And this was called DNS lookup. DNS lookup page. Output looks like NSLOOKUP. Because the vulnerability command injection is where we can actually control. We have an application that's running system commands in the background, and if it's vulnerable, we can actually execute our own command. So that's something that we want to go through and check for. Okay, so once again, mapping the application. What other pages haven't I visited? There's a text file viewer. Here's on the text file viewer, you can choose some option, tell it to submit, and I get all these error messages. It's looking like it's trying to go back. It's PHP trying to make error pages back. Oh, well, it's because I don't have internet connection. When you're testing real applications, you will quite often see error messages pop up like this if you're testing on a staging or a testing environment. Okay? If you see error messages in a staging or testing environment, realize that it may not be true for production. There may be some piece of functionality that got missed when they built the staging environment for you. It's a common thing that I find in staging environments, that they provide a staging environment copied from production, but yet they haven't actually, they don't have all the different servers being replicated on the back end. So we sometimes have different issues like this. Specifically, it's because it's trying to make requests for these external pages online, and I'm not connected to the internet, so that's why it's complaining at me. Okay, then we can do a source file viewer. We can choose different pages. We can look at different pages for this application. Okay, so this is it's not very often you actually find source code, but actually I have tested applications before that were similar to this. They were applications that were demos of a tool, and they actually let you see some of the source code or how it could be edited by the developers. So it's kind of an interesting little page there for what they're doing. Okay, we've gone through, we've visited all the functionality. We have a fairly good idea of what the functionality of this application is. So that's kind of the end of our mapping phase. So on this, we've looked at the logout, we've looked at the session tracking, we've gone through and we've entered in different pages that we've seen information reflected back to us. We did fail to specify any inputs that are used inside of the database. Let's hurry and jot those down really fast. What were some of the inputs that we saw that were entered into a database? Anybody remember any? Okay, so the username, signature, password, anything else that we think was entered into the database? The blog entry, because that was actually being reflected back to us, right? I mean, we could, it was being stored somewhere and we could pull it up later on, so that seems to be saved in there. So the blog entry was also being saved inside of there, and this was all on the register page where it was being inserted into. The login page used username and password as a query mechanism. So register and login. Okay, anything else? What was that? The wiki? Oh, the cookie. Yeah, that's true. We were actually the cookie is being saved inside of the database itself. It's being set by the application. But yeah, the cookie variable's in there. Wonder if that is susceptible. I've never actually tried testing that one. Okay, so possibly the cookie variable. because that is valid input. That's yeah. All right. So that's listed down for some of the different things that we've seen. The other thing we want to review is look at the tracing and timing. Tamper Data actually has that built right in for us. So if we go right into our Tamper Data window, inside of Tamper Data, if you look at options, oops, nope, not options, where is it? Oh, right here, right click. Oh, I've forgotten how to do this now. How do I do the show timings? Why don't I remember how to do this? Okay. We have the timing durations here. It'll actually map it for you too. So we can scroll through this and see which of any of the requests were very long. Here's 102 milliseconds, but it's not that much longer than anything else. What was that? Yes, thank you. Yes, graph all, graph selected. If you go through and graph all, this will actually go through and show you all the different pages that we visited over a scale of time. So here's our coffee break that we took right in the middle. We were visiting anything. And then these were all the pages before, all the pages after. And the size of that blue is how long it took to make that page request itself. So you can see that relatively, they're all roughly the same size. So there's not any single specific request that looks readily apparent to a denial of service type attack. If we see something that's much longer, that's something that could be a denial of service. Quite often, testing for denial of service is outside of scope. For some reason, most companies don't like you crashing their applications or their backend servers. I don't understand why, right? That's our job, to break it. But generally, if you see that, you may want to put that in your that report, or at least let your client know that, hey, this one request seems to take a long time, and it could be something that an attacker could test for denial of services, depending on what resource is taking so long to process it. All right, so that is our graph. Going back here. Okay, so more or less, this is a summary of what we found in our application. Okay, so we did go through and we did find the login and logout pages. These are the variables that were being used to be able to log into the application. We did find that it did track our session state with a set cookie. UID is equal to 5. Okay. We didn't see any method to be able to recover or reset our passwords inside of the application, which from a functional perspective is something they totally failed on providing for us. But since they weren't there, we didn't have to test them for flaws. So we did find various different pages being reflected back to us. So we found inside of the register page that the username, password, and signature was being reflected back. We saw the add to your blog information was being reflected back to me. We also saw on the show log that the user agent string was being reflected back to us. So we didn't actually talk about that. But if I look on this show log page, okay, see this right here, this username, this user string being reflected back? This is coming directly from my browser itself. Okay, so it's something that's input from my browser that's being reflected back to me, and yes, this is something we can test for cross-site scripting. Okay, so that's something else we can add to our tests for cross-site scripting. Okay, user agent string in logs. Okay, inputs that are used inside of a database. Well, we have the login page and the register page, which has the username and password that's being entered back in. We also have the user info page, which allows us to submit the username and password again to see information. So all those are being used for different parts of queries inside of our application. And then we did look at the tracing and timings. We didn't really see anything that really varied there. Okay, we're going to skip through Firebug. We're going to jump straight to discovery now. So looking for vulnerabilities inside of the application. And let's see, we're going to skip the user agent. We'll stay right inside of Tamper Data. Okay, so now let's go through. Do I have XSS fuzzing, SQL injection fuzzing, Tamper Data? Yeah, all right. Yeah, we can do that. Just want to make sure we're utilizing our time here. Okay, so inside of tamper data, here's all the different requests that we previously made inside of the browser. We can go back and start testing our application. So now we're in discovery looking for vulnerabilities. Let's look at our list of different things we have for testing the application. So the first thing we have up here, we have our automated tools. This is what we need a blacklist. Well, we're not automating any tools right now, so we're going to skip this. We don't really need to deal with this now. If we play with automated tools, which we're going to focus more on in the latter session, things like this will take an effect. In fact, when we change to another application, we'll show you why it's so important on this other application. So session variables look predictable. So this is something that we thought looked predictable, that UID. So let's go play with that UID, the login variable, just to try to confirm it. So I'm logged in the application as Justin. I'm going to log out of the application. Now I'm going to log back into the application. Okay, so I'm just trying to gather some. It's a problem with complex passwords when you're doing presentations. Okay, so I've logged back into my application. Before it set it to UID is equal to 5. Let's go see what it set it to my last time logging in. Okay, so there's my post. There's the UID is equal to 5, so it set it back to 5 again to the application. So it's expiring, but it keeps on giving me the same exact one. So not only is it predictable, it's actually fixed per user. They're just using the user ID, which is a huge flaw in the application. Okay, so we confirm that that's a bit of an issue. And why is that such an issue? We can change it to something else. In fact, remember that rule that I have, 5 attempts or 5 minutes? Let's go ahead and pull one of those out right now. Let's actually confirm this through exploiting it. Okay, so let's go into tamper data. We're going to tell tamper data to start tampering. Go back to this page itself, and let's just go to the home page. When you go to the home page, tamper data will intercept that, capture it for us. We want to tell it that, hey, I want to tamper this request. Inside of this tampered request, these are all the different fields that are being passed. Let's go straight to my cookie right here and change the contents. So we know that one of the users is 1, right? It's predictable. We had the whole list of users. Let's go ahead and submit it that way and see what my browser looks like. Now I'm logged in as admin. Kind of interesting. Okay, I can go to home, I can tamper it, I can come down here, set it equal to 2. Why does it keep on changing back to 5? I changed it to 1, and it came back proper in my thing saying, hey, you're logged in as Adrian. When I made a request again, in fact, here, let me show you this. This is something that throws some people off sometimes. If I click on this home page, I'm logged back in as Justin. Okay, so why does it keep on doing that? Why doesn't it remember that I logged in as Adrian? Because the cookie in the browser is set. So every single time I make the request, the browser is changing that. I can also do the same exact thing inside of the cookie as well. So instead of doing it here, let's go into my browser, go another little tool we have called Cookie Editor. Inside of Cookie Editor, you can come right in here in Cookie Editor, find your Matilde. User ID, we want to edit that, change that to a 2, tell it to save it. Now it's permanently changed inside of my browser, so anytime I view a new page, let's tell it not to continue tampering. Stop that. Okay, now I'm logged in as Adrian, who is user number 2. And now every single time I go somewhere inside of the application, I'm still logged in as Adrian. Until I hit the logout button. What? Oh, are they actually setting the secure flag and the HTTP only? No, they're actually not setting that. So we can see that right here inside of tamper data. When I log into the application, I can see that set cookie just says UID is equal to 5. If they are setting the flags, you'll actually see the flag information after it. They're also not setting an expiration time as well, which would all be findings for your vulnerability report. Okay, so they should have HTTP only and secure flags turned on. They also should have a reasonable expiration date on it. All right, so we went to exploitation. We're going to immediately step back. We tried it a couple times. We were within our 5-minute period. We moved back to our discovery, looking for vulnerabilities. So we confirmed that. So we can come down here and add that to our list of findings. So we have a high-level finding. Session variable predictable uses fixed UID for each user. Logged in, actually let's say exploited by logging in as admin and Adrian. Okay, so this is information that I'll eventually flesh out inside my report. With the session fixation, yes and no. Because of the way they had it, that's kind of a more explicit form of session fixation. Usually with section fixation, you can give somebody a cookie variable and they can log in with that cookie variable. With this, it's a little bit different because I'm not starting out with a known cookie variable and not changing that when I log in. Here, they have a fixed static session variable. So it's actually worse than session fixation. Well, we can try it real fast. This is a form of session fixation, but it's a little bit different than what we would traditionally find. We can say, let's try logging in as user ID is equal to 9. Hit the home page. And so unless since they're fixed, it doesn't matter what I give them. It's a fixed session cookie. If I give them a cookie that's not applicable, it's not going to take them anywhere because there's not a user that's correlated with it. So it's a form of session fixation, but it's almost its own kind of flaw. It's absolutely abysmal session choice there. All right, what other things do we need to go through and test for? So we need to test for cross-site scripting on some of these pages. So we were talking about the register page and the add to blog page. So let's go play with the add to blog page real fast. I don't want to go through all of these because of time, but let's go add to blog. Here is my blog page. Okay, I can put whatever I want in my blog. I'm going to turn on tampered data to tell it to intercept it so I can play with it inside of tampered data. Hit the submit button and start tampering it. Okay, inside of tamper data, here's my variables that I can change. It does have some built-in suggestions for you for cross-site scripting and SQL injection. So let's go down to cross-site scripting since that's what we're testing for. We have several different options we have inside of this tool. So we can do a basic alert, which is going to try to do a little JavaScript that does a little pop-up box that says hello, right? So we can actually try submitting that, tell it okay. Let's go back to my page itself. Notice there was no pop-up. Okay, so that actually failed. It didn't actually work for us. So let's go through, try submitting it again. I'll just submit it as empty. So there's the empty value. Let's go through. We can test for something else. We can try a quoteless alert. Okay, this is actually one that we've added for our course. It's not one that's default in tampered data. However, it's one that, oh, you can see that we never actually set it inside of the course. You can add, let's go back in here. There we go, basic alert. That's the one we had accidentally set. So this basically is a basic alert that goes through without the quotes. Because sometimes quotes cause problems. So anytime I'm testing for cross-site scripting, I usually try it without the quotes because you usually have a little bit more consistent results doing it that way. So alert 42, boom, yes, 42 actually popped back up. So we have susceptible to cross-site scripting. Why? Because it could execute JavaScript. Okay, of course, that's not what we're going to show to management, right? Okay, showing that you can do a pop-up isn't really helpful to say, oh, look how vulnerable this is. I can make pop-ups happen on people's screens. Okay, generally you want to show that, hey, I can actually go through and grab somebody's session parameters out of their application. So you can do, you know, like a script Here I'm going to do an alert so you can see it. In reality, what I would do is I would do a request out to an external server that uses the cookie variable as part of that request so I can collect that information. But inside of your JavaScript, you can actually sit there and try to access the document.cookie. Because if they forgot, we already know that they forgot to actually set the cookie with the secure flag and the HTTP only flag on them. So because it didn't have HTTP only, my JavaScript can interact with it and pull down that cookie. So I can say document.cookie, close my script tag. Okay, and now I can see in the pop-up, oh, whoops, we don't want to tamper it. Okay, I can see in my pop-up, there's my cookie parameter itself. JavaScript has access to the cookie parameter, and JavaScript can then send that to anywhere it possibly wants. Here we set it to a pop-up window. What I would do as an attacker is actually send that to myself on my external machine. Have it reference, make a GET request to my IP address, and as the resource or the path to it, actually put this information is for that path. So my log server in Apache would automatically log that information, and I now have valid cookie credentials to the application. Web application firewalls, they will try to protect from such attacks by simply going through and trying to find likely SQL syntax in the requests. However, most of the web application firewalls will actually fail, or they're fairly easy to walk around and get around, because it's very common for applications to actually call document.cookie inside of the JavaScript of the application. That's a common thing that applications will do. And so your web application firewall can't block anytime somebody has a payload for the document.cookie, because if it always fired on that, then it might break the functionality of the application. So you can have it test for it. Most often they're not configured to do so because it's expected functionality in many applications. It depends on the application firewall itself, and if it has been fine-tuned to be specific. The problem is, just like with IDS and IPS systems, most people that purchase web application firewalls never take the time to tune them properly, and so therefore most of them are not configured that way. They can be, but it takes your time and energy to configure them properly. Yes, and once they do, depending on how they actually do it, then we would actually start doing obfuscation, doing encoding of the parameters to see if we can get past the parameters inside of the web application firewalls. For instance, if you were to put up like Mod Security, which is an open source web application firewall, which if you didn't know this, about 50% of all the commercial ones are based off of Mod Security with their own custom rule sets. But the default rules that have blacklists saying, hey, ignore these characters, ignore these special symbols, okay, most of our automated tools have obfuscation techniques to automatically sidestep those and bypass those default blacklists. It's not necessarily an easy thing. Ultimately, we like to see an application properly validating its own input and properly encoding its input and its output, which will solve these problems for the application. That's where the fix needs to be. Web application firewalls should be a temporary solution, or to help you see some of the attacks. Use it for forensic, use it for an early warning system, use it to be a temporary shunt. If a vulnerability is found and it takes us a few weeks to change it in the application, use the web application firewall to temporarily block those types of vulnerabilities. But ultimately, all those changes in the validation should be built into your application itself. Failure to do that is a huge mistake. All right, so we went through, we looked for the cross-site scripting. We could then go through all the other pages that we have for this cross-site scripting, playing around with trying to exploit those. Okay, so we could go through the registrations page and try putting cross-site scripting strings in for the username and the signature to see if that's reflected back, to see if we can get it to run. We did it for the blog. We could try it on the view info page to see if, once we put those strings into the register page, go to view info to see if we could actually cause cross-site scripting to happen. And because they're storing my password, you can literally try putting cross-site scripting strings, JavaScript, in for your password and see if that can execute. Okay, it's always kind of a unique one that's right. And also the user agent. We can actually play around with user agents. If you find cross-site scripting in user agents, which you can sometimes find, have you guys seen those applications where you visit the application, it says, I'm sorry, your browser, we detect that you're running Firefox. This is not a supported browser. Please try Internet Explorer. If they ever see that, immediately try doing cross-site scripting inside of your user agent string, because they know you're using Firefox because of your user agent string. And if they didn't validate that input, which because of that's not coming from a normal user, sometimes developers don't think about validating that, you might be able to go in and change your user agent from Firefox over to script whatever you want inside of JavaScript and be able to find cross-site scripting inside of the user agent string. It's a lot harder to actually exploit and to get your browser, me attacking you, it's harder to get your browser to do that, but it's not impossible. You can do it, just a little bit more advanced technique. All right, so that's testing for cross-site scripting. As you're testing for cross-site scripting, there's lots of resources for you. You can go through and you can use all those different parameters they have inside of Tamper Data to test for it. There's several other tools that are available you can go through to test for cross-site scripting as well. We just showed you just some basic ones because we're focusing on some of the manual techniques that we have here and how to integrate our processes together. So let's go through and now check for some of the SQL issues that we found. So we found that there were some SQL issues on the register page, the login page, maybe on the blog entry, and there might be some cookies that we could play around with SQL injection. Let's go to Tamper. Let's see, stop, okay. Yep, we still have Tamper on. Let's go down to one of the pages like the user info page. Okay, or better yet, let's look at the login page. Okay, we'll submit the login page. There we go. There's my username and password. Let's try doing Justin and password. Just put garbage in for the password. I don't really care. We'll try tampering that request. So here I'm trying to log in as Justin with this random character set of strings. Okay, what I want to do is I want to start testing for SQL injection on these parameters right here. Tamper Data does have capabilities of helping you test for SQL injection. We can go down here to give us some SQL strings, and they have several different options. Now, unlike the cross-site scripting, any of these are safe to use, and you can try them. Some might trigger, some might not trigger. If these don't work, there's lots of good resources online. RSnake's resource on cross-site scripting on hackers.net is probably one of the better ones out there with a whole variety of suggestions on what you can test for cross-site scripting. Okay, for SQL injection, if you're using Tamper Data, do not try going through and using every single one of these. Okay, they have unsafe requests inside of here. Now, for some reason, they think it's okay to attempt to do a drop table of members inside of the application. Now, luckily, most of the time, this isn't going to affect the application you're testing. However, if you're unlucky, and your application you're testing is vulnerable to SQL injection and happens to have a table named members, your client may not be very happy with you. Okay, so do not go through and use all these entries. What we want to do is you want to be more selective on what you're trying to use. In fact, when you're testing SQL injection, one of the first things, I'm going to hit cancel here and look at the page again. One of the first things you want to look at is try to guess what type of SQL query is being made. Okay, here I'm doing a login, so this is going to be a simple SQL query, right? I'm querying the database. Okay, if I go to the register page, okay, what would the register page be? Would that be a query to the database? Probably an insert, right? I'm inserting information in the database. Okay, and if I am deleting a user, it's probably removing information from the database. Okay, be very conscious of the type of request that you're dealing with. You ask yourself, does this request go to the database? If yes, what type of request is this? If the request is something that is removing content from the database or modifying information from the database, stop and make notes. Because if you start fuzzing those parameters and playing with those parameters and you happen to get unlucky, okay, you could possibly delete more than you would expect to, or cause all sorts of damage inside of their database. When you're testing for cross-site script or SQL injection, focus on the queries that are just simply doing queries to the database, because those generally are safe to use. Okay, but if you start playing around with some of the drops, you can test for cross-site scripting or SQL injection there. it's okay to do that, but just realize that you are running a slight risk of being able to accidentally delete content out of the database. So it can be a bit of a problem. So let's hit that submit button. Let's tamper this again. This is going to be a query to the database, so we can play around with some of the different input elements. So we can say SQL injection. Let's go down and try a select all query. So all they're doing here is for the username, they're going to be guessing anything for the username. It doesn't matter. They're just putting a text string there. You can literally change that to your name or whatever you want. Okay, and then what they're going to be testing for is they're going to be testing for the rest of the string, trying to identify that there's something there. Ultimately, we can try putting SQL queries inside of the test when we're testing for cross-site scripting. I keep on doing that. When we're testing for SQL injection. But if we're simply trying to see if SQL injection's there, what's the easiest way to simply see if there's a SQL injection vulnerability there? Just do a single quote, right? We want to try to break the query and try to throw an error message. So let's just go to a single quote initially, submit that, look back, okay, nothing there. In fact, let's turn off tamper data so we can play with it so it's not harassing us. Okay, let's just try a single quote here, submit it. Okay, and we didn't see anything come back. Now, always double check. Don't look just in the screen. Where else do we need to check? In the code itself, because it may not be rendered by the machine itself. You can do that straight inside of tamper data. Actually, tamper data doesn't show you the details. We can do it right in here to view page source. Okay, and we can search through it. You can do a request for SQL. Okay, that's part of the text itself. Okay, so nothing in there. We're not seeing anything inside of the code for that. So close that. Okay, let's try admin and try to do a single quote down here. There we go. The password field susceptible. Okay. So we can actually try to go through and exploit that by, let's turning tamper data back on, intercept it, go back down here, hit the back button. We're going to submit that again, tamper this request. So we're going to be submitting admin for the password, or for the username. For the password, we can go down here to our SQL injection, and you can choose, something that's safe. The select all is generally safe. You can do a select all with comment. Guessing some field names, fairly safe to use. Like values is fairly safe to use. You're guessing your table names, anything like that. But stay away from the drops, stay away from the updates. Those are things that can be a bit dangerous. So what I'm going to do is I'm going to do the select all for the password. And the reason why there's several different ways to exploit SQL injection. Here what we're doing is we're trying to log in as admin, and when it goes to evaluate the password, how it generally works on the back end is a developer will write it such that we go to the database, we find the username, and then we check to see if there's a valid password for it. Okay? What we're going to try to do is tack onto that string a conditional statement saying that no matter what the password is, okay, single quote, or, oops, I changed that, okay, or true. What we're going to do is we're going to try to cause a true statement to happen, because how the developer uses it is if it does the query on the database and the database says, yes, this password exists, that statement ends up being a true statement, and they usually use that inside of their loop saying, if true, then allow them to log in. So we're forcing that true condition. Go ahead and tell it's done, tell it submit, let's go back in, and notice that we have logged in as admin. Okay, so we were able to exploit that SQL injection by making it so that password would always come back as true regardless of what the password is. Okay, so that's finding the SQL injection and being able to exploit it. So that's just a basic application. There's other things we can play with. Probably the one other thing we can play with, once again, we're not trying to hit all the vulnerabilities. Where's the command injection? So we were talking about that one as well. That was one of the things we had in our notes. This command injection, look for the DNS page. Why can't I find it? Malicious. Oh, DNS lookup, right there. We're going to turn off tamper. We're not going to use tamper data for this one. We're just going to do this one by hand. Okay, so here's DNS lookup. When we do a DNS, we knew that went to NS lookup. That's what it looked like for us. Hoost, that was great. I don't think that's going to resolve properly. What do you guys think? There we go. So that resolved properly. Okay, now generally what the goal here is they're passing this input to the application, to the system on the back end. And what we want to try to do to exploit this or to test to see if it's exploitable is we want to pass additional commands. We want to try to control that as an attacker. Okay, we believe they're calling NSLOOKUP. And so we can assume that whatever we put here is being added on to the end of NSLOOKUP. So their PHP script is saying NSLOOKUP, adding on whatever text we have in here. So what we want to do is we want to go through and see if we can add additional commands. Inside of Linux, okay, this is a Linux machine. We can actually, hopefully during your mapping exercise, you identified that it was a Linux machine by doing like an nmap or something like that. Okay, so on a Linux machine, how do we actually string multiple commands together in a single line? Semicolon, okay, or an ampersand, okay, or a double ampersand. We have several different methods we can use it, and we want to go through and test each one. The most basic way is with a semicolon. So we can say localhost, because we want it to do that NSLOOKUP, and then we can try passing something on there. Generally, when I am doing my first initial test, I will avoid any spaces at all, because sometimes the application is actually set to delimit on spaces. So I will avoid using spaces for my first attempt, and then I'll expand from there, and then run a single command that I know will give me output, and I don't need to have a space in there. So what does PWD do? Present working directory, or where am I currently at inside of the tree. This is useful to know because it tells you where web root is inside of the application if it works. Hit submit, check that out. Okay, so yes, we do have command injection here. This did successfully work. Okay, we can play around with it a little bit, and if you play around with NSLOOKUP, if we execute NSLOOKUP without any type of input, NSLOOKUP just kind of errors out, said, I'm sorry, you need to give me something to do. Okay, so I'm going to totally not give it anything NSLOOKUP, just do a start with a semicolon. Let's start using some spaces and see if we can use spaces inside of this. We can do like a cat Etsy password. Okay, so command injection. So very, very apparent. You can sit there and you can do all sorts of different things with command injection. We know that present working directory, oh, that was weird. There we go. Present working directory is server Matilde. That's where we are on the application server. What was that? If you can't use spaces, then you want to try to go back and encode the spaces to see if you can do encoded spaces. If you can't do encoded spaces, then you just try to figure out what you can do. You can sometimes try to maybe piece something together, a character at a time. There's lots of different mechanisms you can use. Generally, if it doesn't accept spaces by coding them, you can usually get them through. If that doesn't work, then you're restricted and you do the best you can think of. So another problem you'll have is sometimes this parameter, the developer may have put some limitation for the number of characters for this field. So sometimes you run into that limitation as well. There was one time that we were trying to exploit an application and we found command injection. However, the command injection we had was very, very small. We were only limited to like 8 characters or something like that on what we could do. And we wanted to basically go through and collect some information off the server, but we were very limited in how we could attack it. I can't remember what it was. We could do spaces, but we were literally down to being able to send like 1 character at a time. What we did was we actually hand pieced together a script 1 character at a time inside of an application by keeping on appending it to a file until we actually built a script that we wanted to run, and then we executed our script. Okay, so you can do that. You just have to be very creative when you have limitations. So, other things you can do, you can go through and we know that server Matilde is the application. You can start trying to dig through the source code of server Matilde. We can say, okay, do an ls of srv Matilde. Okay, so there's all the different files that we can see inside of the root directory. We can see different PHP files for index and for login, for passwords, all sorts of different things inside of there. We have the index one. You can look at any of the source code you want. So let's do a cat of Etsy, no, not Etsy password. Let's do srv Matilde I'm going to copy this. And let's look at the register.php. Okay, so here's actually the back-end code for some of the PHP. Notice some of it is being rendered by the page because remember when we work with PHP files, there's some valid text or HTML in there, so it's going to get valid or rendered as HTML text. However, we go in and look at the view page source. Okay. You can actually come in and see the PHP code as well as the information, the raw source for that page itself. Okay, so here we can actually see when we're doing when it's talking to the database, here's the actual string that it's using to speak with the database itself to make the query. So anyway, so that's command injection. You can sit there and play around with it. You can, if this isn't enough, once again, this isn't interactive. You can't run sudo. If you want to have an interactive shell, then the trick is like kicking off something like netcat, build a reverse netcat shell back into the target server, so then you can use netcat to get back out. If netcat's not present, you can usually do like a wget or a curl or something to pull netcat back into the application. All sorts of things. Really, at this point, it's back to network pen testing. You have a shell, and whatever you want to do with a shell, have it go grab a Metasploit interpreter payload, have it execute inside of the context, and then we start looking for vulnerabilities that will allow me to escalate from my current user to root user. How do we know what user I'm currently logged in as right now? Okay, you can do a who am I? Who am I? Wait a minute, what am I missing here? I thought maybe I was typing something else on accident. Okay, you can also do ID, which is the same thing. It also tells you some of the actual group ID numbers that you have. Okay, so we could log as a www data. So once again, the goal would be here is to, once we get an interpreter on there, is find an exploit we can run to escalate our privileges. All right, it's coffee break. Let's go ahead and take a break. We'll come on back and we'll finish up. We're going to move at the next session. We're going to go ahead and move over to a different application. In fact, for those that want, lunch is coming up. Should we just keep on plugging through? If you want to grab coffee, grab coffee. If you don't want to grab coffee, let me just keep on going. If you guys, let's utilize our time that we have. Okay? Yes. All right. Sounds good. 3-minute break. All right. So we're going to move on to our next target, DVWA. And instead of using Firefox tools this time, we're going to be using some of the other tools we have at our disposal. How many of you guys in here have played with Burp before, Burp Suite? Okay, how many of you guys played with Z-Attack Proxy? Okay, a few people play with Z-Attack Proxy, so we'll choose Z-Attack Proxy to play with. Okay, so the tools are very, very similar. Personally, Burp is my favorite tool. I use the commercial version of Burp as my primary tool that I use when I do my penetration testing. I'm a big fan of Burp. Z-Attack Proxy, though, is an open source tool that's up and coming. It doesn't have all the functionality that Burp has, but it's very quickly approaching that level of functionality. It's not quite as robust as what Burp has, and some of the tools that, while we're getting the functionality, aren't as good as what Burp has. But the benefit is with Zap is Zap, you don't have to have, it's all open source. You don't have to purchase the copy to be able to do some of the vulnerability scanning. You don't have to purchase a copy to be able to save your session state, which is very important to be able to save your session state while you're doing tests. So the testing plan for Burp is going through using Z-Attack Proxy. We'll open it up. We'll use it as interception proxy. We'll use it to spider the application. Then we'll go through and we'll scan for vulnerabilities in the application and then start using it for different types of tests. We can always switch back and forth between some of the different tools as well. But for right now, we're really just interested in trying to find the application or test the application. So here's DVWA. This application, you can get to it via HTTP or HTTPS. The difference is we've installed it 2 different times. If you go to HTTPS, it requires you to authenticate. If you go to the non-HTTPS, you shouldn't have to authenticate to the system. All right, we're going to go up and open up ZAttack proxy. So go down and open up your ZAttack proxy. Okay, so here it is. And usually I will take people through setting up the SSL certificate and configuring Firefox. I don't want to take time today to do that. That should be a fairly straightforward process. That's generally something important to do if you don't want to sit there and being harassed about your browser saying, hey, this is using a self-signed certificate. You know, you're sure you want to do this? Because what all your interception proxies do is they're basically man in the middle of your traffic between you and your website you're surfing. So by generating a certificate and adding that certificate to Firefox, it tells Firefox, hey, this is okay, that we're expecting this man in the middle behavior. Okay, so this is ZAttack proxy. ZAttack proxy was born from and forked from the Peros proxy project. So for those that have used Peros proxy, this is where it's come from. Simon is the lead developer for the ZAttack proxy. Simon Bennett also goes by Sinan. He has taken this project as a means to be able to learn web application security. He's the developer that wanted to get more into understanding security, so he chose this project to be the means to do so. He took Peros proxy, which had been dead and updated for several years. He forked the project, went through and started replacing some of the code. To date, he's replaced about 75% of all the code base inside of Peros proxy. He's also doubled the total lines of code by adding a lot of new features to the project. So it's a very nice tool that are out there. It's not quite to the level where I feel I can use it as my primary penetration testing tool. However, I think it's a very, very good option for people to use as a primary interception that don't have a commercial version of Burp, because one of the biggest downsides to the free version of Burp is you can't save session state, which is important for your tests. So with ZAttack proxy, it is an interception proxy. It does run Java. You can run it on any platform you want. It has things like a port scanner built into it, which is very unique for an interception proxy to do. But it can go through and port scan IP addresses or ports on an IP address for you. So it may or may not be useful. I generally use Nmap. You can do automated and passive scanning. So as you're surfing the website, it'll passively identify vulnerabilities with your application. Or you can tell it to, hey, actively try to identify vulnerabilities by sending malicious input. We'll try to go through and detect those vulnerabilities. It does have spidering capabilities, has some brute force capabilities to brute force unlinked directories, kind of like what Dirbuster does for those that's ever used Dirbuster. In fact, it has the Dirbuster lists built into it. It does have some fuzzing capabilities. Its fuzzing capabilities are fairly immature. We can use the fuzzing in there, and I'll show you how to use those today. But there are still some grave limitations comparing its fuzzing capabilities to something like Burp and some of the other tools like JBro Fuzz. It has capabilities of adding notes, just like most of your interception proxies. But one thing that I like beyond just notes is you can add alerts. You can literally go through and add vulnerabilities, and they have text already built into this for you. It'll actually have text describing what the vulnerabilities are and what the remediations are and different resources and links to get information. It has information for probably around 30 different vulnerabilities already pre-built into the tool. And the verbiage, the text they use is fairly decent text. Probably one of the better descriptions of the vulnerabilities that we have in the open source world. And then it does have capabilities of doing filters and being able to do searches through all your entire requests and responses, which is a feature that's not inside of the free version of Burp. So, all right, so we're not going to worry about updating it. There is a new version out. In fact, on my USB key, I had the new version on that USB key if you're interested in it. But we're running, I think 1.3.2 is I think what we're running in the class right now on the distribution. So we're just going to run with that now and not update it. Okay, so let's go through and map this application. What I want to do is I'm going to step outside of the slide deck just for a minute to try to show an issue that we commonly have inside of our web applications. A lot of times we have web applications out there that when we go to test them, a company will go out and buy a tool that's kind of a point-and-click tool, a point-and-forget tool, to go through and automatically find the vulnerabilities in the application. Often these tools need to be fine-tuned in order to work properly because of issues that they can't figure out inside of the application. I want to show you a problem with DVWA anytime you point an automated tool at it. It's very like some of the issues you'll find in the real world testing larger applications. Okay, with DVWA, it has this nice little security feature right down here where your security is set to high, medium, or low. It defaults to high. I'm not going to change that right now. What I'm going to do is I'm going to show you, if I was to use a purely automated tool, how bad it's going to fail at trying to find vulnerabilities in this application because of this issue. Okay? Then we'll show you how to go through and properly test a tool, how you need to have manual interaction with this automated tool in order to get the best of both worlds and find the most vulnerabilities. Because a lot of time, our automated tools simply don't understand enough of the application to be able to set things, configure things right, or make the requests in the right way to find some of the flaws and vulnerabilities. So I'm going to leave this with high. I'm not going to do anything except for visit this home page. So I have Z-Attack proxy up and running. Now what I need to do is I need to point my browser to use Z-Attack proxy. So in your browser, traditionally you would do this inside of the preferences menu. Inside of SamuraiWTF, we've done all this work for you. Down here inside of Foxy Proxy, we have all the interception proxies that we have already pre-configured. So all you do is choose the one we're dealing with right now. So choose your Z-Attack proxy. And now we're configured to use that. Just to make sure, let's go to click something or hit refresh button. And then go look inside of Zap to see if it saw the request. And it saw the request right down here in the history. Okay. So let's pretend like this is a purely automated tool. Okay, treat it like a lot of the big commercial scanners. It's not nearly as good as the commercial scanners, trust me. But the commercial scanner will have the same issues on this application. So here's DVWA. If we right-click on DVWA and tell it I want to attack it and automatically spider the site, okay, it'll go through and automatically spider the application for us. Okay, so we can see here, drop-down box. These are all the different pages and requests that it saw in the application. Now what I can tell it, now that you know about everything, let's try to automatically scan the site, looking for vulnerabilities. Okay, so here it's going through, so this is our active scan. Here's our progress bar for finding the vulnerabilities. And it's found a couple vulnerabilities for us. Going to my alerts. Oh wow, it actually did find SQL injection. Cool. Okay, a lot of times we won't find SQL injection on this application when it's set to high. Okay, so looking around over here on the left-hand side, this is my site map showing you the organization of the application. Here are the raw requests and responses, and down here are all the different tools. We can organize things however we want. We can organize them so that our tools down here have more room at the bottom and scroll them up. Or if we're ever looking at any one of these tools, if you double click on this tab, it will actually enlarge this tab full screen, so you have much more viewing capabilities. So you can look at any of your tools in full size screen. So see what Spider found, see what the active scan found, going through and reading through some of your alerts. Okay, so it found SQL injection. It didn't find any cross-site scripting that was here on this application though. Okay, so that's one way you can run your applications, to automatically spider and automatically find vulnerabilities. However, most of our applications do much better if instead of automating everything, we add some manual intelligence to it. So what I'm going to do is I'm going to come down here, File, tell it to open up a new session. This is how you save your session, by the way. If I had done all this work and I wanted to give you a copy of this work, say that we're both working on the same test and you're somewhere else, I could save this session, email you my copy of the session. You can open it up and continue right where I left off. Okay, that's a very, very nice feature to have inside of our tools. But I'm going to start over from scratch, start up a brand new session. Yeah, I want to discard my old one. I don't care about it. Double click on any of those tabs will bring you back to the whole page again. Okay, so everything's all fresh and clean here. Now let's go through and do a manual mapping of the application and try to feed some of the proper results in. Okay, the first thing I want to do about this application is I know the security setting causes issues. Okay, so I want to go ahead and set this security as equal to low. Tell it to submit. Okay, so when I set it equal to low, now it's going to, the browser actually fixes it to low. And if I go back and look into my interception proxy, here's the post request where I made that submission. Okay, I can see that my request, I was submitting, hey, I want my security is equal to low. Where is it? Oh, that's weird. How did it get? I had a cookie that I bet was saved inside my browser before I started this whole process. I should have checked on the scanning results that were there. Well, on the first pages. Okay, so yeah, so see how it was set to security is equal to high, and I went to visit the page, security is equal to high, and then on my post request, I made the submission that I wanted the security set to low, and my response came back with a set cookie security is equal to low. So it actually has a cookie parameter actually keeping track of what your security setting is. So now that it's set to low, what I'm going to do is I'm going to go through and manually map through this application. So I can say, okay, here's my home page, nothing much on my home page. Here's some instructions, all the links. These all links go to different pages, but all the links inside of these pages go back to external resources. So I'm not really caring about going to them. I can go to the setup page and click on this reset database, but once again, that's something that could cause problems for my tools, right? My automated tools, I don't want to reset my database because then they're not going to be able to complete some of their tests. So let's not reset the database. This is something that I would call a sensitive page, and I would want to exclude. So go over to your interception proxy, find that inside of your sitemap, and we have the setup.php. That was the setup page. Yep, setup.php is the page that we're looking at here. I want to right-click on that, tell it to exclude from proxy, or not proxy, sorry, exclude from scanner, because we don't want the automated vulnerability scanner to ever play with this page. Tell it OK. And we want to exclude from spider. So that way when I automatically spider, when you spider something, it tries every single possible setting. That will keep spider from playing around with that and accidentally resetting the database for us. Okay, so that's a sensitive page. What was that? So once you've added those inside of the exclusions, if you come up to, where do they have those hidden? There we go, file properties. Inside of the properties for this session, you will see the exclusion lists for scanner and for spider set right there. Okay, and another thing that we did is remember that security page, I already set everything to low. I want to make sure that the automated tools don't automatically change that. So let's go to that one setting, the security.php. Let's go through and tell it to exclude that as well. Exclude from scanner. Okay. Exclude from spider. Okay. And you can do usually the get and the post. Some applications you need to exclude only the posts. Sometimes you need to exclude both pages. Generally, if you exclude the original page altogether, it'll also include all the different posts. Just to be on the safe side here, I'm going to exclude both. Exclude from spider. Let's go into file properties. So I can confirm that yes, I have both the posts and the gets excluded for that security.php page. Okay, go back to my application. Here's a login page. Let's try admin password, which happens to be the right password for the admin. So we can actually get into the application. Okay, not that this application actually requires login to get to any of its features. Here's a ping for free. Let's try pinging an IP address 127.0.0.1. So we can actually test for the application. We come back, notice, red flag. This looks just like the ping command, right? So this is something else that we would want to test for command injection. Once again, ignoring everything on the left-hand side. Pretend like that those don't simply exist. Changing your password. This is something I do if you ever get to a form on your applications and you're doing a manual spider and you get to a changing of the password. If the application lets me, I will always change my password right back to the thing it was previously set to. Okay? The reason why I do this is these automated tools, they will continue to reuse my same data that I submitted to them in the first place. And the automated tools, if they start changing the password to something completely different, then all of a sudden they're going to get themselves locked out of the application and not be able to get back into the application. So I will try to reset it to the same thing. So that's another little trick that you'll usually learn when you start playing with a lot of these tools, is that the automated tools, this helps keep the automated tools in sync a little better. Okay, password change successfully. File exclusion, this is another vulnerability. We're not going to be playing around with file exclusions or the file inclusions today. So user ID, it's just asked me for a user ID. The application is not very specific. Let's say user ID 0. I'm assuming it's a number. We can sit there and we can try through, okay, well, there's one user, there's two users. Okay, that's kind of interesting. We could always play around with trying to fuzz that and do username harvesting to try to extract all the users back out. So we'll save that for later to play with. This looks to be the same form, okay, which, yeah, we're getting the same information out of. Here we're asking for it to upload a file. So I want to choose a file to upload. Here you have a little bit of a conundrum. Well, what file should I upload? I could upload the company logo, but of course my client probably doesn't like me advertising the fact that I'm doing a pen test for them on their web application, especially if it's public internet facing and it's a production server. So if you're ever testing something that's production, you want to be kind of careful and not use something that's going to be offensive or something that isn't going to be linked back or, you know, or breaking your non-disclosure agreements, the fact that you're doing a test in the first place. So if I need something, I'll either grab an image from another user or grab something off the website. So here's something. I'm going to grab this DVWA graphic, do a save image as logo, but instead I'm going to add to logo Utilisec, because usually the file name is never shown to the users. But if I put Utilisec in there, that's something for my company. That's something that my client can use to track down that input that I put into the application so they can extract it back out. So I'm flagging my information so they can find it again, but at the same time, it's not flagged in such a way that their users are going to be able to see that information. Okay, also just go ahead and save that inside of my documents. That image has been saved. Now I can go back and upload that same exact image. So now I have something that, if displayed, it's not going to be offensive or cause any problems, not going to breach my NDA. Upload to it. Goes through and gives me a path. Anytime you see a path, that's always something that's a red flag, something you can come back and play with a little bit later on. Cross-site requesting, what's your name? Justin, hello. Cross-site store, Justin, hello. Okay, we can add some hello information in there. All right, so we already know about the security page. There's a PHP info page. This is something that occasionally on your applications you'll find a PHP info page. It seems to be more common if you are downloading either a commercial or an open source PHP project and modifying, you know, your client uses that to modify their website and build it off of that framework. Often there's going to be like a PHP info page that's like a default link, and if they don't go through and change the defaults, it's sometimes exposed. If you ever see the PHP info page, it is a vulnerability because it tells me the details about how PHP is configured. It also, if you look at the very bottom of PHP info, okay, it tells me all the different PHP variables right now, including all the information about the last requests that were made to the server itself. So if you ever find this, you're going to want to mark it down as a vulnerability. They need to hide these pages. And not only that, you want to blacklist this page from your automated tools, because your automated tools are going to find lots of false positives on this page. Because it shows every single request, and sometimes it's going to show some SQL error messages and all sorts of issues. So it's almost always one that you want to blacklist. Let's come over here. There's my PHP info page. Let's just go ahead and block the top level one. We want to exclude from scanner. And we want to exclude from spider. Okay. Come back into my application, hit the back button. PHP info. Oh, I just went to that page. The about page. And we have the logout page as well. We'll go ahead and we'll log out and we'll log right back in. Admin password. So that way it can see the logout and the login pages. However, generally our automated tools, we don't want them to do the logout page because that will drop them out of session. So let's go through and make sure we blacklist the logout page as well. So there's the logout page, exclude from scanner. Okay. exclude from spider. Now I'm showing you how to do this in Z-Attack Proxy. There's a similar method you use inside a Burp Suite to exclude things out, so Burp Suite doesn't toggle some of these pages. If you're ever using other tools, usually it's up to you to get the exact request and manually feed in the blacklist to the tools, especially if it's a command line tool. So any of the command line tools that's an automated tool by nature, we want to keep track of all these blacklist pages and manually put the proper command line sequences saying, hey, blacklist this page, blacklist this page, blacklist this page. We don't want them to be requested. All right. So with all that set, now we've spidered that website. We've given it proper input for all the different forms. Now let's go ahead and have Z-Attack Proxy spider the rest of the site to make sure I didn't miss anything. It should use the same exact request that I'd made. Okay, so it'll probably find a couple of additional pages which we didn't see links for, which is a normal thing. Okay, so it's spidering. Okay, once it's gone through and spidered the application, you can go through and kick it off, tell it to run some attacks. Let's go through and actively scan the site for vulnerabilities. Oh, that's okay, there we go. A whole bunch of 404s. Now it's searching. As it's running through and actively scanning, you can go over to the alerts and see. Notice before when we ran it, when we opened up the application by itself and told it auto spider and auto scan for vulnerabilities, notice it didn't find any cross-site scripting. Okay, notice it didn't find as many SQL injection vulnerabilities. Now once again, it says 59 different vulnerabilities. This is a very bad habit for almost all your automated tools. Most of the time, when an automated tool finds a vulnerability, many of the tools out there will automatically say, hey, if I have 50 tests that I ran against one single parameter and all 50 of those triggered positive, they're going to tell you found 50 vulnerabilities, okay? Which is not true. It's one vulnerability, except we had several different attempts. Some of the commercial scanners like AppScan do a very good job at reporting this property. Others, and I think Acunetics actually reports it fairly well as well. Other tools, both commercial and open source, do a horrible job at saying, oh, you have 50,000 vulnerabilities in your application, when in reality you probably have 30 vulnerabilities in the application because of the way they're reporting on it. Okay, but you'll notice that the thing we wanted to pull across is if you manually spider your application before you run off your automated tools, you always get better results, okay? Because we're training the application proper input to use. We're training the application how to get to all portions of the application. So when it goes through and tries to fuzz for vulnerabilities, it can do a better job at trying to fuzz those vulnerabilities. All right, now let's go ahead and all the vulnerabilities are very similar. We can test them and we play the same thing that we did on the previous application. Let's pull in some additional tools to play with though. Okay, so if we look at these SQL injections, this application did find SQL injections in our application. Okay, so in this one single form particularly, this one SQL injection form where we start typing the user ID, it found SQL injection by putting in probably a semicolon or something along those lines. Yep, we put a semicolon in, you have an error in your SQL. Now this is something that some people don't catch. Whenever we see an error message inside of the application, does it always mean we have SQL injection? No. If it's an error message that says something about SQL, okay, it doesn't mean we always have SQL injection. However, if the error message is a known error message from the database itself, okay, that usually means you have SQL injection. Whether you can exploit it or not is another question. Generally, it's a point of getting the right, stars to align or using the right tools to get it to exploit. If you see an error message from the database itself, then there's a 99.9% chance that yes, it's SQL injection. If you see some other error message which custom created by the application, okay, mentioning something about SQL or mentioning something about the database, that does not necessarily mean you have SQL injection. It means that some developer triggered on something and is telling you something. It means it could. It's not a guarantee at that point. But when we're dealing with MySQL, this is the common error message you'll always see straight from MySQL. Is you have an error in your SQL syntax, you'll see that quote. That's exactly what they're always saying. So this is the error message they're playing around with. So that's one issue we have. And remember, we had the username harvesting flaw in here as well, or we could harvest different usernames. Let's play with username harvesting, and then for SQL injection, we'll play with another tool, SQL Map, to go through and exploit it. SQL Map's the best SQL injection exploiting tool that we have. So let's do username harvesting first. Inside of my Z-Attack proxy, what I want to do is come back over here to my history, scroll down to the very last thing I did in my history, because inside of my history, I was playing around with that field, and I submitted a 2 for that field. I want to fuzz that, and let's have my interception proxy fuzz that parameter and do an incremental count from 1 null to whatever we want it to go to. Okay? So we can do that to be able to harvest out all the different usernames in our application. So inside of our application, we select it, we find our request. Inside of our request, we highlight the parameter that we want fuzzed, okay, which is the 2. And if you right-click on that 2, we can tell it to fuzz. When you tell it to fuzz, it asks, okay, well, what do you want to fuzz with this parameter? Okay, we have several different options that we can go through and fuzz. We can fuzz for cross-site scripting or any other known vulnerabilities. Okay, they're all organized by category, this drop-down box. So it was on XSS. You can look for different types of cross-site scripting. You can fuzz for different types of user agents. You can fuzz for SQL injection. But we want to go through and just do a numeric fuzz. So we're just going to do a number system, and we want to do a decimal number system. Okay, go ahead and tell it to fuzz. It will go through, open up the fuzzing tab, and start fuzzing it. Now, this is one of the limitations of this tool. I can only fuzz one parameter at a time, which is a huge limitation. If you use JBro Fuzz or Burp Suite, they can fuzz multiple parameters at a time. And the other limiting factor is the version we're using right now. When you tell it to do a numeric system, it only does 0 through 9. The new version, if you download the new version of Z-Attack Proxy, it does allow you to choose your own custom file. So I can create a file very quickly that goes from whatever number of systems I want, 0 to 10,000, and tell it to use my custom file for its fuzzing input. Okay, so that is a new feature that's in the latest version of ZAP. Then when we're going through and looking at these, you can look through the responses. Okay, so there's a 1 inside of my response. Okay, I can search for user ID. Well, there we go. First name is what we want. So admin. So there's my first name, admin. So you can actually do a search string for first name. Capital F. Okay, we'll just do first. What's up with that? Why is that not working? Is it working for you guys? Is it just mine that's not? There we go. Okay, so we can actually search for first. So there's admin. If we look at user number 2, we run a search again. Gordon. Hack is user number 3. So you can sit there and go through and do this. If you wanted to be able to extract them out, then you'd have to probably write a script to automatically extract all this information out for you to do it in a more automated fashion. Okay. The other thing that we want to play around with this request is when we look at all these responses coming back to us, notice that user ID 0, when I was playing with it, never gave me a valid user. You can actually look at your results and see if there's anything in here to help identify that. They're all 200, so that's not going to help me identify which are valid user and which are invalid users. However, if I look at the file size, here I have 4333 for my file size, which isn't a valid user. Then I have all these other ones that are different sizes. and then all of a sudden I drop back to 43333 again on ID is equal to 6. So user number 6 doesn't exist if you actually start playing around and testing the application. So everything past that goes back to the 4333. So we can use that to try to figure out where the users begin, where the users end. Real applications, of course, you're not dealing with 5 users. You're usually dealing with a couple thousand users or millions of users, depending on your application. But you can use these same techniques to try to identify it. My biggest complaint with the fuzzing tools today is most of the fuzzing tools do not give you adequate analysis capabilities to go through and analyze the results coming back. Most of them think that using this information is all you ever need. Okay, it's not, especially when you start doing this real world applications. Tools like Burp Suite, they actually do things better than most of the other ones out there. They give you capabilities in their options to set regular expressions to extract out and will help you flag on those inputs results. But I believe even Burp Suite falls short of what I would like to see for analysis capabilities on fuzzing results. For those that have ever used something like Splunk, be able to have a very, very dynamic way to search through the results and pipe your output from one search result into an inputs of another search result and then be able to graph that graphically. That's what I would ultimately like to see for a fuzzing tool, but it doesn't currently exist on the market today. So literally, if I have to analyze large amounts of fuzz data, if I can't do it with Burp or with a simple script, I will literally take that output, load it up inside of the tool I just mentioned, Splunk. Thank you. Load it up inside of Splunk and use Splunk to analyze it. So that's a trick that I use for analyzing large data sets if I need to have more capabilities than what my current web app tools have for me. All right, so moving on. Let's go ahead and play around with this. This is also susceptible to SQL injection. We tested it with that single quote. Let's actually try exploiting it and doing something with SQL Map. So SQL Map's another tool that we have. In fact, let me show you. I always want to give props to the people that write these tools. Oop, there's SQL Map. Okay, so SQL Map, where you can find it. Quick little summary of what SQL is. Syntax for SQL Map, very simple. It's a Python script, SQL Map. Give it a -u for your target, and then whatever other options you want to pass to it. SQL Map is by far the best tool for exploiting SQL injection. Okay, it's very, very consistent. If you can actually get SQL Map to find the flaw, which is the hardest part, sometimes if you can't get SQL Map to find the flaw, it will never be able to exploit it. But if you can get it to test that, yes, it's there and confirm it's there, then SQL Map has a very, very high probability of being able to exploit it. So it's a great tool for doing that. So let's go ahead and open that up. For SQL Map, you can get to it by applications, Samurai, exploitation, SQL Map. This will open up a terminal to the right location. Now for the audience, let me go ahead and fix my color so you can actually see what I'm doing. Let's do black on white, colors, solid background, close. And let's make that a bigger screen for everybody. Okay, now here's another little bug. I admit I'm the one that made this bug. It was not Kevin. Last time I updated SQL Map, I did an SVN update, and I did it in a subtree, and I forgot to move the contents back up to the main tree. So the tool will take you to SQL Map, but if you look, there's a subfolder, sqlmap.dev. You have to cd into that folder in order to get to the tool. That was my bug. Yes, we are fixing that in the next release. Okay, so here's the tool. First thing, go ahead and take a look at the help page for SQL Map. So do a ./SQL Map --help. Okay, and here's all the different options. Hopefully, if your text isn't as large as mine, it'll be a little easier to read. But if you scroll back up, you'll notice that there's a lot of options, a lot of capabilities. This is a very, very feature-rich application. Okay, when we are using this tool, we already mentioned the --u to specify what the URL is. If we do need to specify post data, it's a --data to do so. If you need to specify a cookie, you have to specify a cookie. Okay, so what I want to do is I want to go through and use SQL Map. Well, that's to connect to it, and then we'll actually show you these in just a minute. I might as well show you while I'm right here. Once you actually find a vulnerability that you can exploit, these are all the commands you can actually use to interface directly with the database. Okay, so you don't have to know SQL at all to use this tool. We simply get it connected to a SQL vulnerability. And then to dump the database, we can actually use the different commands right here to be able to query the database without ever having to know SQL. So it's a very nice tool. In fact, it will also, anything you pull from the database will automatically save in text files for you that you can go back and analyze later. So an automated capability of it. So lots of capabilities. So let's go ahead and try running SQL map against our application. We are trying to test this page, okay, this HTTP DBWA SQLI ID is equal to whatever number. It has to give a valid number, okay, with this submit statement. This is the GET request that we're making. So go ahead and highlight that GET request, and oops, we got to copy it. Once it's been copied, come back over to SQL map, and we want to do a ./SQL map -u, single quote or double quote, whichever your preference is. Paste this information in. Let's go to edit, paste, close single quote. So that's going to be my parameter that I'm going to be passing to it. This is the GET request that I want it to make. Make sure that whenever you give SQL map a valid parameter or a valid query, that it's a valid query and not something that causes the SQL error message to occur. If it automatically causes a SQL error message to occur, then sometimes SQL map gets confused because it expects a valid input. It needs to have a good input so it knows what a bad input is when it does comparisons. So ID is equal to 6, and SQL map, when I pass this along, it'll automatically identify the two parameters, ID and submit, that they are parameters, and they'll start fuzzing those inputs, trying to identify if there's SQL injection vulnerable here. We know there is. We found it. It was very trivial to find with a single quote. So go ahead and hit enter. You'll notice it goes through, starts running all of its different tests. Okay, and then at the very bottom, it'll actually pop out and say, all parameters appear not to be injectable. What's up with that? It said ID is equal to 6, but it says, well, it said right here, it says get parameter submit's not injectable, and higher up it says that the ID is not injectable, or at the very bottom it says all parameters appear not to be injectable. We know it's injectable, right? It was trivial to inject. A single quote caused that error message to occur. What are we missing? The security level of the application. It defaults to what level? To high. And I can tell you right now, it's hard to exploit in high. Okay? So it's set to security is equal to high. We want to actually force it to a lower level so it can actually successfully find this vulnerability. Okay? This is true for all your applications. Most of your applications don't have a hack me equals yes option, right? However, they do have different options which cause the same problems in our application. You do need to pass valid information. For instance, if you're testing a form for SQL injection that requires you to be logged in, you have to give it either the credentials to log in, or you have to give it a valid session ID or a session parameter so that it could actually be logged into the application. Here, we need to pass it that parameter setting the security level. So let's go back to my application to see what my levels were. Here is my get parameter. We have that. Here's my cookie parameter that I need to pass. There's the security equals low. Now, I could probably just pass security equals low. However, it may need to have a valid session ID as well, depending on how the application works. We're just going to play it safe. We're going to go ahead and give it that session ID to use. So once again, highlight the information we want, right-click on it, tell it to copy it. Go back to my terminal. Hit the up arrow key to recall what I previously had. Do a -- cookie. Single quote. Edit, paste. Oh, and oh, don't you love that? You got the carriage return in there. Yeah, there we go. Control C actually exit it back out and allow me to continue right where it was. Okay, and then we'll do a single quote. Don't forget to actually put quotes, either double quotes or single quotes around your material, because otherwise, see the space right here in my cookie parameter? That would actually cause problems. Okay, so once I have that with the valid cookie in there, let's try running SQL map again to see how well it does. And now we can see right here, get parameter ID is vulnerable, so it found it. Okay, that's what it was missing, is that security level and a valid session ID. Okay, do you want to keep testing for others? We'll tell it no. All I'm really interested in is that one parameter anyway, because the only other parameter is the submit. And I have found submits that are vulnerable to SQL injection and other flaws, but usually that's not the case. So I'm going to say, don't worry about testing that. I just want to play with this one parameter. So no, don't continue. And it immediately stops and goes back. This is confusing for people the first time they use SQL Map. Okay? When we use SQL Map, it will go through and test it. And then if you want to actually exploit something, we can rerun that same query and start adding on the different types of commands we want to interface with the database. So it's found it. Let's go ahead and hit the up arrow key to call back our command again. And this time we want to start adding on the different types of exploits onto the end. Whenever I'm connecting to a database, okay, SQL Map has this great little feature called a -- dump to dump the entire contents of the database. Don't do it. Okay, it works fine here, but even here with mini applications, it's still very time consuming. Most production applications, we're talking about terabytes of data. Okay, don't start trying to download terabytes of data. Your client's not going to appreciate that. So what you want to do is you want to very strategically go through and navigate through the database trying to find out what's there. So you can do things like a --dbs, which is going to connect to the database and show me all the databases inside of it, that it has records inside of its schema. So hit enter. Notice right there, fetching database names, available databases, right there. There's all the databases we have available inside of this machine. So this is using that SQL injection flaw to exploit that vulnerability and connect to the database. So here's a list of my different databases. Once I find a database I'm interested in, which application are we tested right now? DVWA, so let's focus on that database. Okay. So I'm going to, instead of run the dbs command, which lists the databases, I'm going to now pin it to that database. To do that, you do a -D, which means, hey, I want to fixate you on this one database and not mess with any other database. Database is DVWA. I don't need to have quotes because it's a single word. You can put quotes when in doubt. They don't hurt anything. Okay, and now what I want to do is let's look at the tables. Okay, let's go through and do a listing of the, TBLS. Okay, to show me a list of all the different tables in the application. Whole word out, sorry. I don't know what I'm thinking. DBS, they actually pulled out the vowels. There we go. So now we actually have the list of our tables. We have the guestbook table and we have the users table. Okay, once again, once you find a table to use, to tie to, you can do a --T to pin it to one of the tables. Let's look at just the users table. And from the user table, you can do like a --count. Let's see how big that table is. Thank you. Okay, so we see we have 5 different entries inside of the users table. Okay, so if inside of that users table, that's small enough, we can go ahead and dump meaningfully now. So instead of doing a count, let's do a --dump to see what's inside of those tables. And it pops back up. Hey, we recognize that there's possible password hashes in here. Okay, so looking at the contents, do you want to try to crack the password hashes? Sure, why not? Let's try to do it. It goes through and does either a default dictionary, a custom dictionary, or whatever you want. It's going to default to 1 if you just hit enter. So let's hit enter. And it pops back up. Do you want to use common password suffixes? You can tell it yes or no. I'm just going to tell it no. So it does it a little bit faster. Starts going through trying to crack all those different entries. And we can see up here, there is all the contents. Here's the different names. So let's see. It starts out with your avatar and your first name and your last name and your password and your user ID. So here's on one of the users. Here's the password that's in the database. It's an encrypted form. And it was able to go through and successfully crack that password as password. What was that? This is a bad little issue with SQL Map. Sometimes it recognizes that there's hashes in there, and sometimes it doesn't. How many of you guys actually had it recognize there's hashes? You notice I didn't run anything different, right? Oh, okay. Come Come on. Hold on, I got to reset my terminal. Okay, so that was the command. Nope, that wasn't the command. That was the command I ran right there. So I pinned it to the DVWA database, and then I pinned it to the user's table and did a dump. So sometimes it finds that there's hashes. It's supposed to automatically figure out anytime that there's something that looks like a hash of a fixed value. It's like the normal value of an MD5 or normal value of a SHA-1 or a SHA-256. It should actually automatically detect, hey, you have hashes here. Do you want me to try to crack them? And do a basic dictionary attack. It does not consistently find it. Okay, sometimes I'll do demos and it does it. Sometimes I'll do demos and it doesn't do it. I just kind of go with whatever the application has as it's using the tool. But when it finds it, it's always nice to be able to see the data. And notice when you run it multiple times, it doesn't actually show you. But if you ever want that information is actually stored inside of a file that we ran it. Oh, see here you want to do the dictionary attack again. Sure, let's do the dictionary attack again. Yeah, we'll take all the defaults. Exactly. And if you don't, if this doesn't do a basic brute force, you can go back and take these hashes into rainbow tables if you have a rainbow table for that type of a hash. In this case, I believe they're MD5s. So if you have an MD5 rainbow table hash, you can use another tool that's more specialized at cracking them. So then, of course, you have applications which simply don't store the hashes and they store the actual passwords, which is brilliant. But yes, you can. Did you see what on the questions it asked me? Let me scroll back up. It was asking, let's see, using right here. What dictionary do you want? So you can basically say, use the default one built in, or you can use a custom dictionary to point it to something else, or you can actually use a file that lists several different files to use. So for those that have ever used FuzzDB, FuzzDB has lots of different dictionaries inside of it. You could literally point it to a file that references the paths for each of the different FuzzDB files you want it to use. Okay. So anyway, so that's SQL map. That's being able to exploit SQL injection without having to know SQL. Quite often, if it's going to be a very simple attack like what we did in the first one where I'm testing login screens, I'll usually try to just exploit that by hand, by forcing that true statement to actually make it occur. If it's any other type of a SQL injection, and if I want to deal with a database, I won't worry about trying to pass all the SQL stuff by commands, by hand. I'll just open up a tool like this and use this tool to navigate around. This tool does have other capabilities. You can have this tool go through and open up command shells for you. If I remember right, I don't think it works quite right on inside of DVWA, but you can play around with that. That's one of the options it has is SQL map. If the database permits it to, it'll actually upload like a PHP file or a JSP file, whatever language you have. And if your database can write to the web root, it'll actually write that file and actually bring up a little pseudo terminal for you. So you can actually have quote unquote command injection that we created to be able to have a terminal that's being exploited via SQL injection. Yep, like upload a PHP shell. It has its own built-in ones that it uses. Yeah, it has its own. It's if you look at the man page, like I said, I don't think it works for this tool. Come on. I guess not the man page. It doesn't have a man page. SQL map -- help. Pipe that over to less so we can get through it a little easier. Shell. So right there, SQL shell to prompt for an interactive shell. We can try it. If I remember, I don't think it works in this application. Okay, so we can get rid of that. Do SQL shell. Okay, do you want to retrieve the SQL output? Yes. Okay, PWD. Oh, that's a SQL query, a SQL shell. Sorry, that's actually passing SQL commands. They have another one. Control C. Exit, quit. Oh, OS shell. There we go. So if you want to just pass raw SQL, you can do that. You can do this for your command. The language that we're using is 3. It's a PHP, and it's not in var dub. Do you remember where it was when we were testing the application? It was like SRV Matilde, right? Oh wait, wrong application. Oh, and it's not just Matilde. Hold on, let's hurry and come up here and cheat. Where's my command injection flow? Okay, so we can grab this, copy it. Paste. So that's our root. And let's see, unable to retrieve any path information. Yeah. Anyway, so you can sit there and you can play around with it. If I remember right, I wasn't able to get DVWA to work, but you can actually get this work in a lot of cases where you can get an interactive operating system prompt on a machine via SQL injection flow. So, but yeah, SQL injection is a great tool. You can also use it to try to, force different things like Metasploit interpreters. If you can get a shell, you can actually try to grab a Metasploit interpreter and try to use it that way. Anyway, it just gives you a nice launching pad to do different things inside of the application. So they have a lot of built-in things. Look through the help menu. There's a lot of things you can play around with. We have on the SamuraiWTF, we have Matilde, DVWA, WebGoat, Samurai Dojo. We have several different applications in there that have SQL injection vulnerabilities. So play around with SQL and SQL map, trying to play with each one of those different vulnerabilities to see what you can do with the applications. And once again, all the vulnerabilities we're talking here, we keep on using PHP on a Linux machine. These vulnerabilities are true on any application, regardless of the programming language, regardless of the web framework you're using, regardless of the operating system you're running on. So, I mean, play around with these tools, and they work with all these other applications. So that is SQL Map. How many of you guys have played around with SQL Map before? Okay, so a couple people in the room. It's a fun tool, right? For the people that never played with it. Very, very nice tool to use. How can you fingerprint those? There's actually a couple different ways you can fingerprint Joomla. In fact, maybe we have about 15 minutes left. I wanted to show you one other tool. How many of you guys have seen Beef before, the browser exploitation framework? Okay, so let me show you Beef, and then I'll open up to questions. Really fast, let me answer this question. So how can you actually detect the framework that's being used? Quite often when I'm trying to do a test and I'm trying to detect which framework or what they're basing their code off of, quite often just looking at the home page and looking at the code itself, there's usually going to be some footer information or some meta tag information that references the code it originally was. So it'll reference Joomla project or something along those lines. If the developer has gone through and removed all reference to Joomla or whatever framework he's using, another thing you can do is test to see if the favicon has been changed. A lot of times developers will forget to change the favicon. And do you guys know what the favicon is? See this little thing right here? This little teeny icon up here? A lot of times developers will forget to change that. Tools like Nikto, which is the oldest tool in the planet for web pen testing. And this is like the dinosaur of web pen testing tools. Okay? It's still very applicable. I run Nikto on every single site I test. It runs very, very quickly. But the nice thing about Nikto is it's still updated. They update it about once a week, once every other week. So make sure you keep your rules updated before you run it. But they also have a favicon database that they'll actually use to fingerprint which framework you're currently using. If they forget to update that favicon icon, it'll look it up. It'll MD5 hash it, look up inside of its database, and determine which of the different frameworks or projects it came from. So that's another way you can try to identify the framework. If they've removed all reference in the code and they've changed the favicon icon, then it's really up to you to recognize it from having played with it before. So. All right, so the other tool I wanted to show you is, let's play around with Beef, the browser exploitation framework. So inside of here, let's go ahead and pop over to localhost. Before, when we talked about when we talked about cross-site scripting, we showed you how to, test for cross-site scripting. We showed you, we're interested in cookies. We're interested in doing things to the application. Well, when we're trying to exploit cross-site scripting, one of the best tools we have at our disposal is the browser exploitation framework. What the browser exploitation framework does is it tries to take all the browsers that get trapped by your cross-site scripting and turn them into kind of like a little botnet. We don't call them botnets when we're dealing with beef. We actually call them zombies. So zombified browsers. But it works just like a botnet. We have a controller, and all the browsers that have run our cross-site scripting exploit, they actually get connected back to our controller. And their browsers, as long as they stay on a page that we can control, or we can do like a pop under and keep them connected back to us, their browser will continually talk every few minutes to our controller to see if we have additional commands that we want it to run. Okay, so we can actually control a little army of browsers here. So to do that, go to your controller, the Browser Exploitation Framework controller link inside of the Samurai tools. There is a bookmark for this as well. If you forget about localhost, look in bookmarks. All these tools are found in bookmarks. Okay, here's the browser or the beef configuration page. Just hit apply. Okay, and finish, and it will take you right into the tool itself. Okay, so this is setup beef. This is the main controller. Notice on the left-hand side, we don't have any zombies available. What we need to do is we need to actually get a zombies. To testing the tool for our purpose here today, we're just going to cheat and use their little built-in process to spawn a zombie for us. Okay, so up here under view, tell it to spawn a zombie example so we can play with it. When you spawn a zombie example, it opens up a separate window and lets you know if you want to actually hook other people into this, you need to have them execute this code. So if I ever find cross-site scripting and I want to use beef, you take that little script right there, you paste it into whatever code you have. You do have to go through and modify this one piece right here. Okay, modify the IP address to be your public IP address or your IP address that that machine can talk to. Okay, once it points to your controller, okay, it should hook itself right back in as a zombie that you can control. So back in my controlling window, I can see I have one zombie. Notice it has figured out it's running on Linux and Firefox is what it's controlling. How does it figure that information out? The user agent. Okay, remember browsers always are very verbose. Hey, I'm running on this operating system using this browser. Okay, so just use the user agent to figure this out. Inside of beef, what we do is we go ahead and we select the zombie we want to work with, and then we can go through and send different options to it. You can do simple little things like you can harass them with pop-up messages. Okay. Hello, I own your browser. Okay, send now. And we wait. Notice the module code over here says it's been sent, and it immediately pops up. Because remember, I'm also the victim. I'm the attacker and the victim at the same time. So this window, this pop-up, if you click on it, it'll actually bring the other page to focus. This pop-up actually came from this window. Okay, so this is something that I just sent to my victims. If I have multiple victims, I can send it to all my different victims that are out there. Okay, you can do things like clipboard theft. This only works in certain versions of Internet Explorer. I think it was Internet Explorer 6 and 7. Actually, it should tell me when I go to the plugin module. Okay, yeah, before 7. Internet Explorer in Windows actually had access to the JavaScript had access to the clipboard. So it could actually go through and pull information out of the clipboard. So if you have somebody that's running that version, you could actually see if whatever's inside of their clipboard. Because we all know that it's always safer to cut and paste your password instead of type your password, right? Remember the news that was going around, recommendations for doing that? Yeah, well, unless you're using one of these browsers on Windows. Other things you can do. You can deface web pages, actually put new content up inside of the web pages. You can go through and detect to see what technologies they have. So we can say, hey, let's see if my zombie, oh, notice the zombies sometimes get lost. It's actually a bad problem inside of beef. Just hit the refresh button. And that usually causes it to recheck its zombies and come right back up. Oh, no zombies. If you do end up losing your zombies, oh, because I closed the window. I killed my own zombie. Let's go ahead and respawn it. Okay, wait for a second. Just have it show up. There's my zombie. I can go through and I can detect to see if they have Flash installed inside of their browser. Anytime you send code, always look in the log summary over here. The module code's been sent. Flash is available in the browser. Okay, so Flash is turned on. So I can actually send them Flash payloads if I have a malicious Flash payload that I want to send them. Okay, you can detect other types of quicken plugins. You can detect extensions. You can detect to see if they're running inside of a virtual machine instance. You can, if you want to have more capabilities, you can have a raw JavaScript console that I can actually add JavaScript that I want injected into their page, and it would immediately inject it into their page. So if you want to have more control over what's going on, you can rewrite elements in the page with this. You can put some JavaScript in here that pops up a little message saying, sorry, we had a problem. We just accidentally logged you out of the screen. Please re-log in, and give it a username and a password field that you can go through and collect from them as they're typing in their username and password, because session variables are nice to have, right? But if they're hiding the session cookie with the secure flag so that JavaScript can't access it, I can't steal their session. However, if I can trick them to type in their username and password again, Beef can actually collect that information back out to be able to steal. Okay. Other types of modules it does have some of the exploits that are available for some of the different browsers. They don't have many exploits in them because there's a finite capabilities on whether Beef can actually exploit a vulnerability or not. But these are some of the ones that it can exploit. So Internet Explorer 6, it does have one for XP Service Pack 2 with the IE bind shell, so the different CVE numbers that are in there. It has one for Safari. It has a couple denial of service for Firefox and Chrome. So there are a couple different exploits it can launch directly by itself. And if that's not enough, they do actually have several different Metasploit connections too. So if I bring up Metasploit and I have Beef people connected to Beef, I can redirect them from my Beef server over to my Metasploit to grab payloads. Or if you really want, you could do like an autopwn to Beef, to have Metasploit go through and try every single possible attack against their machines. And once again, autopwn is probably not the best thing to launch in a real penetration test, especially against a whole bunch of browsers that you have connected to you. But it does work. I mean, you can actually do that if you don't mind causing absolute hectic problems with some of your users that are out there. Other network modules. It does have capabilities of detecting the host IP address and host names. It doesn't do this with JavaScript because JavaScript doesn't have access to the IP address of the local host. But what it does is it sends down a Java applet, and Java applets can actually have permissions to look up the IP address. So it uses that Java applet to pull the IP address and then passes it back to JavaScript, which then sends it back up to the Beef server to extract out the IP address. So you can detect these. You can try to detect to see if they're running inside of a Tor tunnel. You can go through, and this is always a fun one, detect which websites they visited. This is brute forcing the browser history. Okay, they give you a list of probably around 50 or 60 different. Actually, that's more of 50, 60. At least 100 or a couple hundred very, very common websites that they could visit. So if they've ever visited any of these websites, then they'll actually come back up. Since I'm not connected to the internet, I haven't visited any of those websites with this current browser, but I have visited DVWA, and I have visited localhost, and I have visited Matilde. Okay, so I can go ahead and say send now. Notice my code has been sent over here on the right-hand side, and the results come back up. It says, yes, this person has visited DVWA. They have visited localhost and Matilde. Okay, what they're doing is they're not literally downloading your browser history. They're actually brute forcing it. They're presenting a list of different sites that you've visited or that you could have visited, and then they're going back and using your browser's built-in capabilities to actually change the link color of the sites that you have visited compared to the ones you haven't visited. They're just using JavaScript to go through and do an eval, or you can also use cross-site script or CSS pages to do the same effect. There's like 3 or 4 different ways you can do this. So they'll automatically do that. You just give them a list of the sites you're interested in. You can give them a list of these public sites, or if it's an internal site with sensitive sites, you can go through and give them a list of internal applications that they've visited, internal IP addresses, especially if you're going against network team trying to find all the Cisco's with the web interfaces open. Okay, give them internal IP addresses ending in a .1 or a .254, and you actually find all sorts of network devices. Oops. Okay, and then finally, some of the last thing that's kind of fun. They do actually have some tools like this exploit for asterisks, which has absolutely nothing to do with web applications. But since voice over IP uses a similar protocol to HTTP. It happens to be very, very permissive, and it sees all these HTTP headers and it kind of ignores them because it doesn't understand them. But then it gets to the payload and it starts processing these voice over IP headers in there. So this actually is an inter-protocol exploit that they've been able to work as a proof of concept of how we can actually exploit a vulnerability, a known vulnerability in older versions of Asterisk using Beef. So use your zombie browsers to go out and attack the Asterisk server. So kind of a fun little tool. Anyway, so that is exploiting cross-site scripting with Beef. So we have about 5 minutes left before lunch. Do we have any questions that want answered from the workshop? Yes. So when you're working on a test, I always preferred working in pairs. I like having 2 people on every single application I test. When that's the case, generally what we'll do to keep track of our test is most of the time we use a wiki page that's set up behind a VPN, a protected VPN server. This gives us the freedom to be able to control what that output looks like, which is good and bad. We've tried using other tools that are more fixed with the type of information that you put into it. That's a little bit more organized. I like the fact that it was more organized, but the problem is you were very constrained with how you were actually inserting your data into it. So we've always found that a wiki is actually best because we can put data into that wiki however makes the most sense for the tool. So, and then usually when inside of the wiki, we'll have different pages for our notes and our findings. And then we'll have another usually section for the wiki for the final findings, all the confirmed vulnerabilities. And we'll start fleshing out the report there with just bullets of, hey, this is the vulnerability, this is where it was. We'll upload a screenshot to that same exact wiki page. And then when I go to build the report, if it's me or my companion or we're both building the report, then we'll do the report inside of Word and we'll just basically use that wiki page for findings as a kind of a framework to start building that report. Sorry, was there a question up here that started getting asked? No, okay. Any other questions? All right. Enjoy lunch. I'll be around if you guys have any questions. I'm actually here through Sunday, so feel free to grab me as you're walking by. If you want my contact information, it is on the slide deck. I'm fairly easy to find online. If you want a business card, I do have some business cards too. If you want to come exchange business cards, I'd love to keep in touch with you guys. Thanks, guys.